see in a minute, it does double the voltage apparently while maintaining the current. And that, my friends, is over unity. Let's get started. Yep, we got a little bit of movement on that side. Now we're going to switch it to 400. And now it's moving. Holy shit. Hi, I'm the benefactor. I apologize recently for my absence in content. My computer crashed, but I just had to get this information out. Today, I'd like to demonstrate my Rodin coil and the effects that I've been witnessing over the past few weeks. I'll be going over unity and magnetic synchronicity. I haven't run this test yet with the neodymium sphere. What we will be doing is placing the sphere in the center of the vortex and seeing if it can capture and react to the magnetic moment of the generated electromagnetic field. And supposedly, if we can do this correctly, we can generate such a magnetic synchronicity that the sphere will keep on spinning even outside of the affected vortex where the magnetic field is condensed and contained. So we can take it outside supposedly and it'll still affect it, and even power off the coil with no energy going into it, and you can see the residual energy still affecting it as it powers down. I'm following in the footsteps of Daniel and Erica Nunez. I'm recreating some of their experiments to see if I can basically do what they did. And so far, the results have been very promising. The uniformity of the coil is not ideal. I screwed up a couple of parts, so it's probably going to be a little bit less efficient than the claimed 10 times voltage output. But as you'll see in a minute, it does double the voltage apparently while maintaining the current. And that, my friends, is over unity. Let's get started. Alright, as you can see, I have my input and output multimeters hooked up. The input hooked up to the stereo output, which is going into the input of the Rodin coil, channel A. Channel B, which is not connected to channel A, is outputting into my own custom circuit. So basically, we are inputting a tone with the tone generator, and with specific frequencies we can manipulate the coil. Get our magnetic pole detector in there.
My research has led me to find that the coil exhibits different properties at different frequency ranges. I'm starting to believe that the coil might have multiple resonant frequencies, one lower and one higher, to reflect the duality of magnetism and electricity. After all, magnetism and electricity are two aspects of the same phenomenon, and what we see in this coil design is a very strong electromagnetic field generated at the low end. For my coil, I've seen this start anywhere from 0 to 40 Hz. And on the other end of that duality, an over-unity energy production at the higher frequency range. The sweet spot for my coil seems to be around 1 kHz. Following in the footsteps of giants like the Nunez's, for a layman like myself, took months of painstaking attention to every detail of their coil designs. I went to great lengths to learn everything I could about their research, deconstructing and reverse engineering their videos. I even found an unlinked Google search to one of their website pages that had a treasure trove of information in text form. It was descriptions of all their videos that had been taken down off of YouTube. As you can see, I'm using my digital pole detector to try to determine where the pole is and what orientation. However, in this test, I was not successful in actually detecting the South Pole. Previously, I had detected a South Pole, but I hadn't detected a North Pole, which is very unusual. This is what we would call a magnetic monopole. The two counter-rotating magnetic fields are compressing and condensing the North Pole, I think, into a point that is negligent to the system, meaning contained within the vortex you have one useful pole.
So we can adjust the power level with the gain here. Right now we're at 10, we're at virtually no power. So right now we are going to demonstrate the low frequency range, which has a strong electromagnetic field that's generated in the vortex of the coil. And what's unique about this coil is that it's a stable, contained effect, where a normal electromagnet, it's just going to attract or repel something. This will only have that effect within the vortex, which makes it a stable system. Alright, so we're going to input 20 Hz sawtooth. I'm going to turn up the gain a little bit. Oh. As you can see, there's a strong electromagnetic field generated at the center, at the vortex. Get our magnetic pole detector in there. Clearly got an electromagnetic field, but we are not picking up any pole. This is what we should see. This is what we should see. Only it's switching back and forth. See, back and forth. I don't see any of that. Alright, so we're going to move on to the over-unity test. And I'm going to demonstrate how you can actually apparently get more out than in tiny increments. This serves as a proof of concept for overunity, breaking the conventional thinking of science that says we cannot achieve more output than input. But if you look at how Tesla achieved maximum voltage output, sure, it's at the cost of current, but what is he doing achieving that? He's resonating the load. He's using a resonant circuit. But he is not choosing the path of least resistance for the energy. When you combine the resonance, resonating the load with the current, or resonating the load with the conductor, and the path of least resistance, which is this toroid, the path that the energy wants to flow, you essentially can create overunity. And what we're doing here is we're taking the resonance, combining it with the geometry, and we're taking the geometry of two counter-rotating magnetic fields and putting them on top of each other in such a way that we create a torsion physics, a torsion effect that essentially what Malcolm describes as is creating a monopolar point on the equatorial plane. It is creating a monopole. And this is very significant in many different respects because mainstream science says this is impossible. We haven't yet proved the existence of monopoles. Here we go. Alright, so we are still pumping 24 Hertz into the system. Right now, we increase the power a little bit. I'm just going to run this coil and do a little bit of power. And we're going to let it run. See up the voltage or up the we're going to let this run and then we're going to basically take a temperature test. Let's check the voltage here. Alright, so we got 3.6 volts AC going in, 5.6 volts AC going out, and I'm sure if we check the current will be slightly higher on the output side like it has been. Let's do that real quick. Let's check the current for you. Alright, so we got 0.26 amps going into the coil. Alright, 0.29, 0.3. Wow, and then to verify that the voltage was being accurate on this multimeter, 5.4.
Now would be a great time to pause our video here and explain something to everybody. Despite my calm demeanor in the video, what has been accomplished here cannot be understated. This system is apparently putting out 55% more energy than it's taking in, 0.9 watts on the input and 1.4 watts on the output. 155% efficiency. I keep thinking to myself, something is wrong. Every instinct in my body tells me this shouldn't happen, but it is. That little voice in the back of my head saying, you hooked something up wrong or you misread something. But I've checked my connections, I've talked to every known electrical engineer I could find, and I've done the math over and over. Overunity has been achieved, and now would be a great time to put a like on this video, comment, share, and subscribe for more. Thinking about my setup, there's really no way that you can hook up the multimeters wrong and get an inaccurate reading like this, especially since the multimeter reads lower on the output like it usually should at the other frequency ranges outside of its resonance range. we have multimeter A hooked up to the output of the stereo amp receiver and the input of the coil, and multimeter B hooked up to the output of the coil. But channel A and channel B, the output, are not connected. They are lying on top of each other in a bundle of wires, but the two channels are not directly connected. This means that what's happening has to be some kind of inductance. Replications of this experiment will be needed to verify or refute these results and determine what exactly is happening. And I have put together a quick do-it-yourself guide so that you can try to replicate these experiments. I have a link to this in the description below. This guide will be periodically updated with more results and more theories as I progress with my research.
So this multimeter is good at picking up the AC voltage, especially at higher frequencies, which is unusual for a cheaper multimeter. But unfortunately, it does not pick up current very well, especially at higher frequency ranges. So when you see the frequency get past a certain point on this one, it just takes a... Well, we can easily just swap them out for now until I get a spare. This is a very good multimeter, by the way. Alright, so I'm going to be monitoring the current on the output side for now. Let's monitor the voltage input. 2, 5.4 or something. Alright, so we've been running this for a few minutes, and crank it up a little bit. Since this is restricting the circuit, we can crank it up a little bit because it's plugged into the milliamp setting, which, you know, is going to restrict the circuit a little bit to read it as milliamps and more accurate. So, let's take a look at the temperature reading. So the temperature did go up slightly. It went up about 1 degrees. 1 to 2 degrees it looks like it went up. The temperature before the ambient, before the coil was running, was around 77.4. So it is heating up a little bit, but again, this might not be the ideal geometry. I don't have it completely symmetrical. As you can see, it's kind of bent in some areas, and the bundle isn't uniform like it should be. So we might have inefficiencies, which is why I suspect we're seeing a lot less output multiplication than predicted. But this thing should be getting hot to the touch. It's not even getting warm. As you can see, the ambient of the table is around 77.7. 78.6. Right in the vortex. On the edge of the vortex, where the energy actually is traveling. Remember, it's not going through the tore, it's going around the edge of the tore. 83.4. So it is gained a little bit, about 3 to 4 degrees. Actually, about 5 degrees. So it's gained about 5 degrees. Yeah. Concrete is a little cooler, 76. 81, 82, 83 on the outside, let's see, 82, 83 on the outside, 81.8, 82. Alright, and we've been running this for how many minutes now? At least
4 or 5.
4 or 5? So a regular coil at this point, especially if it's expecting look at that, 7.4, because I pumped up the gain a little bit. If it's expecting 7.3 volts on the output, this coil should be at least getting warm to the touch. It's not even breaking a sweat. All right. And look, oh. That's weird. Put in a little fuse.
Since Daniel and Erica Nunez went silent at the end of 2022, their website store, which had sold their custom-made Vortex frames, has been shut down as well. Their Facebook and Instagram are silent, which was really unusual because the couple had been posting quite frequently on their social media and had recently been excited about a newly obtained lease for a property in New York to develop their technology even further. Within their unlinked website forum, I managed to find an item list for one of their inexpensive setups, and I tried to recreate that here. I ordered the exact parts described, even going so far as to order the very specific stereo amp receiver that Daniel uses in some of his videos, an Insignia receiver that I will have listed in the description below. As you can see, my custom-made circuit allows for the use of both AC power for the 3 LEDs and DC power for the DC motor via the use of a 4-diode and single capacitor. The Nunez called this design the PoE Vortex Coil. It stands for Peace on Earth, but I just call it the Nunez design to give them credit. After all, they were the ones who came up with this easily made sliding disc frame for our coils. They not only made it, they perfected it. And we need help trying to recreate their advanced version 3 432 Vortex coil. Jordan from Alchemical Science might be able to tackle this one. The frame needs to have a very thin V-shaped opening for a single wire set, not like the big spaces we see in Jordan's frame, or the one I am currently using. We simply set a single layer of wires down so they are symmetrically and evenly placed on top of one another, like we see here. This is their most advanced design, and it will supposedly eliminate the ozone problem with the coil. As some of you might be aware, it is not safe to use the coil inside while it is outputting high voltage due to its tendency to release ozone. The geometry playing a critical factor in the performance of a system can be explained by examining why a coil produces a magnetic field in the first place, while a straight line wire does not. The geometry is the determining factor for the presence of a detectable magnetic field. The closer you get to this precise geometry, the more you are choosing the path of least resistance for the energy. In a straight line wire, you couldn't be further from this path, since nothing in the universe travels in a straight line. Thus, it is within the realms of conventional science to assume that geometry is an integral factor to maximizing the performance of any system. This is not just one system. It is an all-in-one system, a transformer, a resonant circuit, a Tesla coil, a strong electromagnet. It is the holy grail of physics, a system unaffected by the weight that it carries, perfectly mimicking a black hole. From the macroscopic to the microscopic, we see plasmoid structures implode in on themselves in the same way that stars do. This isn't a coincidence. It is theorized that at the back of every black hole is actually a white hole. If you think about it, this makes sense. When you have matter being condensed into a single point, it's not just going to stay there. It has to have an exhaust. It has to have somewhere to go. When also thinking about a black hole, we must ask ourselves, why is the hole there in the first place? If there is such a strong force condensing matter, time, and light into that hole, why does it exist? Marco Rodin believes it's because there is something emanating out of this hole that is causing it to not close. Radiant energy, the only thing in the universe that travels in a straight line. It is impervious to everything and can penetrate anything. After I was done filming, a couple of friends came over to check out the coil in action, and we decided to do an impromptu cymatics test.
Okay, we're gonna start with 300 hertz sawtooth.
So on this side over here.
We're at 30 on the gain for the stereo. Yep, we got a little bit of movement on that side. Now we're gonna switch it to 400. And now
On
it's
this side.
moving.
Can't tell. What side? Oh, right here.
It was easy. Yeah, we could see it a lot better on the one before, but it is moving a little bit.
I wish this was censored though.
Right, yeah, that's probably what it is.
Oh, yeah.
It's probably not centered.
Yeah. No, once you
You
touch
can
it,
clearly
yeah,
see.
but you're affecting the vibration with your hand.
Oh, there you go, yeah. See?
Yeah, that's why I said on this side.
Okay, so we're gonna increase it another 100 hertz. And now it's moving on.
It's moving towards this.
Yeah, now it's moving on the opposite side. So it is switching polarities, like you said.
Alright, let's see. Beyond what?
Okay, another 100, 600.
Now it's coming here.
Switched again.
It's all over.
Yeah. I think we need a more even surface to tell indefinitely, but yeah, it looks like it's
That's
moving a little bit.
Oh, look, this looks centered though at 700. See, it looks like it's centered
I
in
can't
the
see
middle.
where it's moving.
Right, yeah, a little bit. Another 100. We're at 800 hertz.
Reduce take it down to like 25.
Why isn't it moving anymore?
We're at 25 on the gain.
That's at 800. Go back to 500.
500.
500 at 25.
Okay.
No, it's not going to do anything because you're turning down the gain, so.
Yeah, but then, we reduced it there.
Oh, to find the sweet spot.
Yeah, remember how we had like 2.1?
This experiment is for a viewer, Katie. Katie is a loyal viewer and a loyal supporter of the channel. And as you all know, I don't just like to hoard love, I like to spread it. So this experiment is requested by Katie. She requested that I put water inside the vortex to see what happens. I'm going to do that. Just a little bit. Okay. We have a tone generator and we're going to put 7 hertz into it. All right. Let's turn it up a little bit. Get a shot of that too. Okay. Doesn't appear to be doing much. So what we can do though is we can put a tiny magnet in there. And it's flipping around a little bit. You know, this gives me a good idea, Katie. Why don't we get ferrofluid, put it in the vortex and see what happens? I think that it'll start spinning. experimenting with this and discovered it while you were calling. We're gonna put it on 7 hertz. And look at this. Look at this. Look how fast it is spinning, dude. Look at this. It's insane. Wow. Wow. Shaking. With all the complicated physics and engineering involved in these systems, here's the kicker. It wasn't that difficult to actually achieve this over unity, which is why I'm prepared to host workshops for everybody interested in learning how to recreate these experiments. I need more independent researchers who are ready and able to recreate some of my experiments to verify or refute my findings. After all, what good is free energy if you're not going to tell anybody how it works? Keeping science open source is key. Developing this over unity system, it feels like I found a cheat code for life. A system that is able to actually output more energy than it takes in? It seems like it's wildly impossible. However, I cannot dispute what I'm seeing with my own eyes, the empirical evidence in front of me. It makes sense though. When you look at how nature utilizes energy, it does not waste energy. Magnets are nature's over unity systems. If you calculate the amount of energy it takes to pulse a magnet compared to the number of years it can sustain itself against its own weight in gravity, you clearly get more energy out than put in. I think a lot of this has to do with the diminishing study of the ether. The dismissal of such a critical component, such as the ether, leads us astray. When thinking about magnets, north and south poles, it's best to think about them as inflow and outflow. When you think about it this way, it makes more sense. Why do opposite poles attract? To understand this, we must first look at this analogy.
So we hypothesized that there was some sort of current circulating in and around the magnet, analogous to the current circulating in a coil of wire, and that this was the cause of attraction and repulsion in the magnet. But currents of what? We hypothesized that the vacuum of space was filled with a fluid of some kind, what you humans used to refer to as the ether. We speculated that these special objects were able to spin up the fluid ether in and around the magnet, generating currents that would then result in attraction and repulsion, analogous to what we saw in the coils. To test this hypothesis, we spun a couple of cylinders in a pool of water and watched their behaviors. Here is a video of one of these experiments. In this video, the cylinders are spinning in opposite directions. The spinning cylinders generate currents in the water surrounding the cylinders. When these cylinders are spinning in opposite directions, the currents generated between the two cylinders will be moving in the same direction. Therefore, according to our rule, same attracts. The cylinders should attract, and they do. In this experiment, the cylinders are spinning in the same direction. Again, this is going to generate currents in the water surrounding the cylinders. When the cylinders are spinning in the same direction, the currents generated between the two cylinders will be moving in opposite directions. Therefore, according to our rule, opposites repel, these cylinders should repel, and they do. So, it seems plausible that the function of the magnet could in fact be described by and explained by fluid dynamics.
I believe this inflow and outflow could be the ether, nature's natural zero-point energy, only flowing from one pressure differential in the ether to the other. Constricting the inflow, or North Pole, essentially produces this radiant energy, as it is not able to return and convert back into the ether, which Malcolm Bendel refers to as DC energy at rest. Recently, I went on Crypto Alchemist's podcast, Free Energy Fridays, to update everybody on my research. I gave a quick demo of the system and went into a little bit more detail about my setup and theories. If you're interested, I highly suggest you subscribe to Crypto Alchemist's YouTube channel, and I will link the video in the description below. Big shout out to Crypto on that front for giving me the opportunity to discuss these results with a group of inventors and free thinkers with valuable insights. They gave me a host of great ideas for future experiments and led me to develop some of my own theories about the coil, as well as teaching me a few things about electronics. As it turns out, I might have to pump the coil with at least 25 volts in order to determine the claimed 10-degree decrease in temperature inside the vortex of the coil, as noted by Daniel Nunes in his own research. This cooling phenomenon is called cold electricity and has been claimed to happen when a system has achieved overunity. So what do I do now? Now that I've actually accomplished what I set out to do so long ago, I've already demonstrated the Rodin coil is a viable option for free energy. Do I hang up the lab coat? No sir, there's still more work to be done. More experiments to replicate that I have not yet been able to, like the wireless transmission of energy from coil to coil. I was also hoping to be able to demonstrate the coil at this year's Cosmic Summit. However, it looks like next year is more of a possibility. In the meantime, I will continue to push my knowledge and understanding further than ever before, in order to demystify some of the valuable options held within my coveted rare edition of the Practical Guide to Free Energy Devices. So stay tuned and subscribe for more updates on my upcoming new show, The Benefactor's Guide to Free Energy Devices. Check out my website, Beneficence TV, for exclusive merchandise, research database, and community forum where you can stay up to date on my ongoing research and share some of your own projects. For those who are professionals or comfortable enough around high voltage equipment, please check out my do-it-yourself guide for the Nunes design. It's up to you all now to try and replicate this, and I will do my best to help you in any way I can. The easiest way to reach me is by leaving a comment on one of my videos, but feel free to reach out to me via my Facebook Messenger icon located at the bottom right corner of my website, or you can just email me at beneficencetv@gmail.com. Much thanks to Crypto Alchemist, Jordan from Alchemical Science, and the Martin Fleischmann Memorial Project Discord channel for helping me with this project and supporting the page. You guys are awesome. For more on Zero Point Energy, stay tuned to Beneficence TV. What's going on, everybody? I'm the Benefactor. I'm an independent researcher looking into the Rodin coil and other areas of fringe science. You can call me the Bill Nye of fringe science if you like. I try to teach these complicated and convoluted areas of science to a more general audience. And today we are going to be preparing our Rodin coil frame for our full day workshop, which will be I have it scheduled right now for the 8th, Sunday, because I do not have enough funds to buy the coil. It is kind of expensive. It's like $80. I have like half of that. So if anybody wants to donate and speed up that process, my Cash App is linked in the description. It is Beneficence TV. But today we are going to be going over how to build the coil frame, how to put it together, and I'll also be going over some of the materials, or actually all the materials that you'll need for the workshop. So it's not that involved, but I want to make sure that everybody who attends the class has all the materials ready so they can build it. Hey, what's going on, Joe? How you doing, Delta KB? Everybody's here, it looks like. We're gonna plug in the glue gun, let it heat up for a minute. Obviously, we're going to be using a glue gun for this. I don't recommend anything else, simply because the plastic is so thick and you want it to be sturdy. Unless you have a more durable adhesive, this is the cheap and convenient solution right here. And again, this setup is specifically to save you money. So yeah, if you have more expensive equipment and materials, feel free to use them. But the way that I'm doing it is the cheapest way possible without affecting the efficiency. So this coil frame, I believe, is Dragon 7. I think that's his name, Dragon 7. I have it linked in the do-it-yourself guide. I'm going to put it in the chat in a minute. But the coil frames themselves come from Alchemical Science. He has, Jordan from Alchemical Science has a custom frame that I am not using. I'm using the Dragon 7, I believe, coil frame. Very basic. Still the vortex-based math spacing and geometry. It should do just fine. It's what I'm using for my other coil, as you can see here. Right there. That coil, though, is a little bit smaller than this one. This is the full-size one. This is the Big Daddy. So we're going to plug in the glue gun, let it heat up a minute, catch up on chat, and put my gloves on, and we'll get started. There we go. That's what I wanted to do. You like the cone on the Rodin coil? Yeah, it says great job or well done or something like that. Sean says he loves the ending. You talking about of the live stream video that I made? I thought it was pretty cool. All right, so as you can see here, when you get your printout, you will have a big center disc that will fit your smaller rings. And depending on the coil design, you could have more or less rings, but I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have 13. No, 12. So I have 12 here. I think Nathan was gracious enough to print me an extra one. So what we're going to do is just one by one, we're going to fit them like this and go around. But we're going to do it one by one. And we're just going to go around the edge. I don't know if you can see it right here. Go around just a thin layer on the edge on either side. And that's all you need. And then you let that dry for a minute. And then you move on to the next one. And again, these easy sliding disc coil frames were contrived from First Stop Energies, Daniel and Erica Nunez and their team. So this is all thanks to them that we have these sliding disc frames. Before, people were using just the donut, and that was very hard to do. Again, you don't want to overdo it. You just want to get a thin layer so those two surfaces are bonded. Make sure you keep pressure and keep them together, because if they're not, if the epoxy is not dry and hardened, then the disc could slip out. So make sure that you have a firm grip on it while you're doing this. Just a little bit at a time. Spread it if you have to. Just going to take it a little bit at a time. And it's very simple. It's put on some music. It's a meditating experience, if you ask me, making these coils. It's very mellow, very cool. So now we are having a spiritual experience making a Rodin coil. There's a shadow person behind. No, that's my girlfriend. She's probably going into the kitchen. This is a 1-bedroom apartment. All right, so as you can see, I just put a little bit on either side I'm continuing to hold it though. I'm continuing to put tension on it. I want to do that for at least, 3-4 minutes. Give it some time to dry out. Put a fan on it if you have to, but you can see as it's starting to turn a little white. That's the process. Sorry about the autofocus. There we go. But that's the process of it drying. Doesn't take too long, but for it to fully cure, we want to leave it at least 24 hours. That's what I recommend. And that's why I'm doing this ahead of time. I want to make sure that this is set up and it's good in place and it's not going to jiggle or wiggle. All right, now at this point, I'm going to loosen it up a little bit and just see how it holds. It seems to be pretty stable, holding pretty good. Just give it a slight jiggle. Yep. Okay, so we're going to set that here and catch up on chat. Let that dry for a second before we move on to the next one. We got 11 more of these to go. And then I'll go over the entire material list. And actually, while I have a minute, I'm going to put the do-it-yourself guide in the chat so you can do and take a peek at that if you're ahead of the class. All right, so that is the link to the do-it-yourself guide that I whipped up for the Rodin coil here in the setup. This is, if you want to follow along more easily with the class, I recommend that you have this up and looking at it. There's pictures in there, and it gives you information more detailed than my videos on how to set up the Rodin coil with this, pretty much any stereo amp receiver. Tomorrow I'm getting a new stereo amp receiver, and we're going to test it out on a new one. I'm kind of excited to do that because, that old stereo amp receiver I was using, it was an Insignia RS2001, which was the exact one that Daniel Nunez was using in his experiments. And I got that for a reason, but it was old. You could tell the back was a little corroded, so it was used. And eventually on live stream, it just blew up. So we're going to be testing that out tomorrow. Probably maybe either before the Fringe Think Tank, or if Nathan decides he wants to have something like that on the show, I can do a little demo of that as well. So we'll see. But tomorrow we're gonna hook that up. I plan on that. As long as it gets in the mail, gets here. It's coming in the mail from Amazon. So again, there are variables that are dependent. Hey, Nathan, how you doing? What's going on? Good to have you here. Everybody's excited to have Nathan in the house. He's our local celebrity. Anyways, Ben, haven't forgot about emailing you back. We'll get to it. Yeah, no. Anytime you get to it, you get to it. I realize we're all busy. We have lives, and sometimes we forget. So I know. God knows I do. So prayers for Panda Cat. What happened to Panda Cat? I missed something. Oh. Oh, your cat's in hospice. I'm sorry to hear that. Yes, lots of prayers for Panda Cat. Yeah. You know, animals, especially the domesticated ones, they're our responsibility to take care of because we domesticated them. You know, we put them in this world that they're not naturally supposed to be in. So it's our job to take care of them. All right, let's move on to the next ring. Oh, it looks like I have to reload my gun. Looks about right. All right. Now again, we're gonna slide the next small disc in and keep a firm grip on it. I recommend pinching it at either point. See, I have my middle finger on one end and the thumb on the other end. So that's what I recommend. You can even switch if you have to, but always keep that pressure on it to make sure that this is bonded correctly, because you don't want it uneven. Again, this is, you know, this coil is about symmetry. And even though I screwed up a couple of parts on this coil over here, my first one, it still worked. So I was actually surprised, but you want it as even as possible. So if everybody wants to go ahead and introduce themselves to chat, this is considered a class. I know it's a pre-workshop, but it is a class. So feel free to take this opportunity to introduce yourself. And if you intend to make it to the full class, let us know. Just going to do a little bit at a time. I might have to set this down. Actually, no, I got it. See, this is a awkward moment because I have to make sure there's tension on the reloaded cartridge here. This is a very poor design. It's very cheap, but just keep pumping it and it should work. There we go. You almost have to be an octopus to do this. Yeah, I might have to set it down for a second. Just using the reloaded cartridge to push the end of the expended cartridge here. You know how these cheap glue gun designs are. There's a catch mechanism and it has to catch the new one, so I have to push it. So anyways, remember, tension on the ring, eye on the ball. Well, you get the idea. And just slowly. It's still not coming through. I have to push it a little bit more. Seems to be stuck. We're going to give that a minute. Might be the heating element. All right, I'm going to be right back. I think it's clogged. I'm going to get something to unclog it. Tool. And what this does is it sucks up any excess solder when you melt it. So, you have to do that real quick. So what I'm going to do is heat this up again and see if it sucks it out. It's just a little clog. It's old. It's not old, but it's just cheap. It's real cheap. You had a question. Let's see. What was your question? Hey, could you post your question again? I don't see it. Oh, what is your thoughts on this? I think free energy comes from the reverse energy or the spike of collapsed magnetic field. Yes, that's actually the theory that Nathan was going over. It's the reverse spike in the collapse of the field. That's something that Bedini talks about a lot, actually. So you're right on the money there in terms of what our theories are. Again, these are all theories until mainstream science wants to man up and start doing some of these tests too. Yeah, I don't think that's going to be enough suction. I have to get a needle. All right, I'll find something to stick up there. Oh, there we go. Perfect. All right, that should work. There we go. Yeah, baby. Now we're talking. Shove that bad boy in there. Now we're cocked, locked, and ready to rock. Yep, there we go. Cool. All right, remember, pinch point, thumb and middle finger, or whatever finger you prefer. Tension on the ring, and gently apply, like so. And if you miss any spots, because I know when it dries, sometimes you notice, oh, I missed a little spot here or two, feel free. Go over it with some second details, you know. Every good paint job needs a second coat. Am I right? All right, one side done. Very carefully. Might want to angle it. All right. So second ring is done. We're still going to apply tension, though, for a minute before we let go and let it dry for a little bit. We'll check the first one. First one looks good. Yeah, first one's actually pretty dry. And it's deceiving. It feels like it's all the way dry, but it's not. To fully cure, you have to give it some, I think they recommend like 6 hours, but I would say 24 hours, you know, and depending on the moisture content of the atmosphere that it's curing in, that could affect it. All sorts of variables. But at the end of the day, this thing is very efficient at what it does. And when we hook it up, you'll see that it actually generates more energy than it takes in. It's accessing the 0 point and generating that extra, or basically opening a gateway to that extra energy that's all around us. And it's fairly easy to do. You just follow some simple rules. Don't make the silly mistakes that I've seen countless people do trying to recreate these coils, and you'll be good. All right, we're going to set that down. And before we go on to the next one, I'm going to catch up on chat here and see what's going on. A reaction from perturbation of the ether. Yes, exactly. When you're generating the electromotive force, you're perturbing the ether essentially, and people just ignore that perturbation. The effects of it are, like back EMF. You see that back EMF in circuits, and people just are taught to ignore it or push it out of the system because it's, they consider it noise, but it's not. It's extra energy that you can utilize if utilized correctly. It's negative energy or negative electricity. Sorry. It's energy is energy, but it's negative electricity. Hey, we got old man Nathan, old man Builds in here. Nathan, you want to come on? Old man.
And see what's going on.
Yeah.
Hey, how's it going, everyone?
As I said, our local celebrity.
Sorry, there you go. I had to pause my thing. I was watching your show at the same time. So I see you gluing it. What else is going on there? Sorry, I was just finishing up my live stream stuff.
No, you're good. I was trying to catch some of it myself. You're talking about some cool UFO stuff. I have to go over it later because that was pretty interesting. So
What's
yeah,
up,
right
everyone?
now,
Say hi to everybody out there in the chat. What's going on, guys?
Yeah, we got Nathan in the house. Nathan from Old Man Builds, and he's reverse engineering the gravel flyer.
Oh, sorry. Oh, these things. I don't have my hearing aids in, man. Kind of messes with my ears a little bit. Sorry about that.
Oh, it's all good. So I was just explaining, we're putting together the frame here, and it's just simple. We got a glue gun. We're gonna take our time with it and apply a little bit on the sides. And I was explaining how we want to do this ahead of time to give it enough time to cure.
Yeah, I'll throw super glue on it when you put in each one, and then hot glue it afterwards. That way they stay right where you want them, and you can just go in a little quicker. But one at a time's cool, as long as it works.
Yeah. This is the process that I don't recommend rushing because, like I said, it can be very meditative. It's a Zen experience. Making these coils, any coil really.
Ben's going to another dimension over here building his coil. I get it.
Yeah.
Picturing how it's gonna work. I get it. Right on.
But yeah, so as you can see, this is the Big Daddy, and we're gonna be using a red magnetic wire, so it's gonna be a fireball, literally.
What size you using, Ben?
Wire is gonna be 24 gauge.
Nice.
Mm-hmm. And I was just explaining earlier, I was planning on doing it the Sunday the 1st, but my budget constraints, I had to push that back a week. So when I get that wire in, because wire is expensive, it's like $80 for that spool, and I wanted to get the 5-pound spool so I have an extra.
Yeah. Well, how much did it take last time in the big spool you used?
So last time it actually didn't take the full spool. I used a 1 pound, and it took a little less than half, I believe, or no, a little more than half. So.
Well, that's a bigger coil too. That thing, when I printed it out, man, I'll be honest with you. I looked at the center hole and I'm going, man, that doesn't look anything like the size of his. You know what I mean? Like,
well, I was gonna say, I think I remember decreasing the size of it when I printed it out, the original frame. So this might be the full size.
Yeah, the cool thing is now you want to rotate the magnet in there. You may not even need the little bowl that you put it in. You have plenty of size in there now.
Right. Yeah. And also, and here, let me set this down so I can give you a visual here. Because until you wind something like this, you really don't know what you're getting into. When you spool your wire, you want to have something not like a traditional spool. You want to have it long, right? So you can fit it through the hole.
right? And that's one of the biggest challenges is if you're doing a small one, you have to fit your spool through the hole or just feed the line individually like I did with the smaller one. But
Hey Ben, give everybody a perspective there. What size pipe is that, and then what size of the hole you think there is?
I'm not sure. I'd have to measure it.
About a 1-inch pipe right there?
Yeah, about a 1 inch and
Maybe 1.5 inches at the most.
right.
It's got to be like a 3 or 4 inch hole.
At least. Yeah, maybe 6 inches, I'd say.
That thing's pretty big.
Yeah. So this might be 2 inches diameter.
2 inch? Really?
Yeah.
That's one big hole in there. I knew it was big. I forgot how big it was.
But it's nice. It's I like the big design because it's the full design that we're supposed to be working with. It's the full size coil, and we should see a lot more stable energy coming out of here, I would assume.
That's so cool. Yeah, I can't wait till you get it all done, man. Because I'd like to see that magnet. Just put a little dot on it or a line on it so we can see where the rotation's going. It's slow speed.
Oh yeah,
that'd be awesome.
That is a great idea. So somebody brought that up in chat, and that's what I'm going to do tomorrow. Assuming I get the new stereo amp receiver, I ordered a newer one, a smaller one, but a better one.
Okay.
And I'm going to hook it up to the green coil that I have over there. And I don't know, we'll run some experiments, but I could definitely do that tomorrow. Test it out.
Do you have diodes?
Yes.
Okay, try a couple diodes on your way out. So make sure anything doesn't pull back on it like it did last time.
Right.
So I'd try it out and see if it works. You know what I mean? Just hook it to a speaker with a couple diodes in it. Just make sure it flows one way and it doesn't give you any losses.
So just put the diode in between the speaker wire.
Yeah, well, like how your speaker wire comes in, you put a diode here, okay, and then it goes into your speaker right here. So you just want to see if it has a difference in sound so that when you're doing testing if there's a difference or if it works at all. That's probably a perfect way to test it, and then go ahead and put it in your machine. That way hey, if it pushes back, it's not the back EMF's not going to kill my receiver again.
Right. Yeah. So if it shuts down from the back EMF, then I know this is probably not going to last very long.
Well, yeah, but you want to give it a kind of a test before you run it through. You don't want to keep blowing them up. You don't. But
I could just use I could just use the LED diode.
I don't know. You'd have to test it out. Whatever's going to blow before it blows your system is what you want.
Is anything that'll push it back?
Yeah, I mean, you could try LED diodes and see if it even does anything or has any loss in power. I would test it a little more for you. Run right into it. You don't want to have something blow up you just bought.
I think I do have a couple of directional diodes that aren't LED diodes that I could just hook it up to, and then just put the positive towards the speaker, right?
Yeah. So basically, they have that little line in it.
Yeah, for the positive, I think. Or
so the flow goes into the line. So the big side on the black on the diode would be on this side where your source comes from, and then you hit the line, and then that side that goes out, that's your flow direction.
Okay, so I want that to be facing back towards the speaker.
Yeah, just think of it as the little gray line when you look at it. The shorter side is the side that it can't go in. That's the way I always see it.
That makes sense. With the spool, after we get done with the frame and I go over the materials list equipment's list that we're going to need, I'm going to saw off a couple of sections on either end. So we'll make a nice groove to wind the coil.
Right on.
So we're going to get our hands dirty here.
How long does it usually take, Ben?
To make a coil?
To make the winding for it.
You talk about actually winding the coil?
No,
winding.
From what I understand, you have to tie it to a post and then you swirl it.
To twist. Oh, to bifile it? Yeah, to twist it.
Then you wind it on your pipe to get it ready.
I'd say anywhere around 20 to 30 minutes if you're, quick and you're not obstructed. Like
I had some
That's not bad.
obstructions. I'm in an apartment. So in the back, people might be walking around, like, so I have to block it off with cones and make sure somebody's standing there so nobody like hurts themselves. And I got to be quick about it. So I did it in about 20, 30 minutes. And that's, again, you have to go back and forth from one post to the other 24 times to make, but, and here's the thing. If you don't have enough wire, if we run out of wire, or you just want to do some experimenting otherwise, as long as you keep it an even number between the channels, like 12, 16, 18, it should produce some kind of over unity effect for you. As long as it's not.
How do you calculate the distance that you need to go, because it's a bigger coil than what you used last time?
So I'm just going off of what Danielle Nunez said. And last time, I forgot that I had shrunk the coil frame, and I was doing 50 feet, and it was way too long. It gave me a lot extra, honestly.
Okay.
So I'm assuming that 50 feet is going to be good for this one, but I'm going to do 55 just to give it some extra wiggle room. Because I don't know if that 50 feet is just going to come right up to the end, or because I like to have a little bit of space for the leads coming out.
Okay.
Yeah. So again, last time, I think I twisted it too tight. And this time we're not going to do it so tight. We're just going to check it periodically and twist it enough so they don't come apart. Right. I think last time I twisted them a little bit too tight, and that tension, it broke one of the wires. Like it microfractured all. Yeah. And it didn't produce it wouldn't flow electricity through it. So I had to disconnect another wire to even it out. And that's where we're at with the green one. But, this one should be perfect. This one should be perfect. And this, honestly, I'm excited because this one will be perfect for phase 2 of testing with the Bedini circuit. And
So
really,
just to repair that, if you can get to it, let's say if you can get to it, you have to strip it, you have to solder it, and then you have to put another coating on it. Okay. So you want to maybe get a spray coating to put a couple coats on it, or the better one is like a brush coating. You know what I mean?
Okay. So you can repair it.
Yeah, you can repair it to fix it, but the whole thing is that wire comes with a coating on it, because it's just basic copper wire, but then it has a coating on it, and the coating is so thick. So if you can separate it just a little bit to get that coating on there, a piece of paper in there, something like that, get a nice coat on it, and then rejoin it, you can reattach it. People do it with their Tesla coils. It's never perfect, but it will get you through to test it.
Right. I can imagine people fry out wires all the time with the Tesla coil experimenting.
It's frustrating, man, when you get to a real thin wire on a Tesla coil and it breaks. Yeah. Right here, some guy said 50 feet way too short. So that's Bug Irish.
This one?
Hold on, that's our buddy Ian right there.
Yeah. He said 50 feet is way too short.
So give them the dimensions side to side. Like put another wheel on the opposite side and give a dimension so you can.
So I'm going to bring the other coil up here in a second. 1 second. And I'm going to put them side by side too. Give me 1 second. I'm going to bring this other coil up.
Well, that's a good idea right there. Yeah, Ian's right. Use rope. Check it out. Make sure you got the right length. Hey, Ben.
Yes, that is a good idea. I didn't think of that. So
you heard it? Okay.
Yes. So this is just a comparison. Here, let me back up a little bit.
I'd go to the dollar store and pick up a dollar, rope. Wow, that's like way bigger.
Yeah. So this is almost like a POE mini.
Oh, yeah. Look at that. That's a good size difference right there. That's for sure.
Like I said, it's a fireball.
Yeah, I would definitely do the rope.
Yeah, no, let's do the rope. That's a great idea because Bog is right. I'm sorry, Ian is right. This might, I have no idea how much wire I'm going to need. I'm just estimating. And I don't want to buy a big spool of wire and screw it up and waste all,
Yeah, that'd be a loss right there. That's for sure. That's a good idea there, Ian. He should know, man. He sent me some calls today, man. He's working hard over there.
Right.
Yeah, no, it's actually let's put this on the side so it can stand up here. But yeah, no, he's made some good stuff, and I'm excited.
It says right here, what size coil? I could figure it out for you. So if you have a dimensional distance between the two wheels there, you got a tape measure, Ben?
Let's see. I think I do. Give me 1 second.
Yeah, we'll give everybody an idea of what's going on here. You know what I mean? What we're looking at. That way, I'd love to just do it once, or Ben would probably. God, I don't know if I could deal with that. The little hooks they have when you build them like this, I would put them straight. I don't like those little hooks that go in there like that. I know there's a reason for them, but it just looks like a chip wire to me. You know what I mean? Take the coating off of it. So let's see what we got. Hey, Ben, we can't hear you. Your mic's off.
My bad. You want me to measure the inner diameter?
Well, give them the inner and give them the outer.
Okay.
You know what I mean?
So let's measure the outer first. Okay, we got the outer diameter.
Just under 10 inches. So just under 10 inches for the outer diameter. And the inner diameter.
Ian says, just use the rope. My math isn't good enough to figure it out.
4.5 inches for the inner diameter.
Wow, that's big. I can fit my Tesla coil in the center of that.
Hey, that would be an experiment. That would be a good experiment for one live stream.
Look, the one right over there, man, that gold looking one right there. Mm-hmm. Both of them are 4-inch diameter, man. They go right in the center of that.
And then the two fields combine. Oh, wow. That would be crazy. I wonder what would happen. What if the donut just shoots right up?
Oh. That'd be cool, man. That'd definitely be cool.
All right, we're going to go on to this next ring. So, Nathan, what have you been up to today?
You know what, man? I'm just going through, and I've been talking about the field and stuff like that, and I wanted to get it out there, exactly what was going on with it and how it looked, because a lot of people are confused. And even when we did it live last week, it was like there's still a lot of confusion. Yeah. And I talked to Gerald about it, and we kind of came up with a kind of a middle ground a little bit. Mm-hmm. And I think this pretty much presents what it is. So that's kind of what I was up to today. Just working on that, and I had to clean out my garage. God, Ben, I had stuff everywhere.
Yeah, I got to do some cleaning too.
I've been resetting my high voltage stuff, so I've been, blasting some stuff out. Right. And I got stuff all over the desk to worry about, the island behind me.
Yeah, that's the thing, you get to having fun building some stuff, and after a while you look behind you and there's a bunch of big mess. You got to clean it up.
Yeah, it was bad. That's real bad.
Yeah.
I have to get back to work in here and clean some things up eventually. You know what I mean? Mm-hmm. I got some molding to put around the door. I got a light to fix. You can see it behind me on this side. It's hanging there because I put that room in, and I had lights in my ceiling, and now I got one hanging. So now I need it can't go back up in there, like that. It's got to get run a new wire. So I'm a fat guy, man, and it was 110 degrees outside. I'm not getting in that attic, okay? That's a disaster waiting to happen. Free wheelies coming through the roof at that point. You know what I mean? It's just all kinds of wrong. So I decided to wait and let it cool off a little bit, and I'll fix it.
Yeah. Yeah, you definitely don't want to overheat yourself. I know it's tempting to work and when it's really, really hot out, but if you can't, or if you have another choice, take the day off, because I was out there and I seen guys, I'm out there in construction. I see guys all the time that try to push it and they end up fainting or, passing out or throwing up.
be kind to your body, you know,
Yeah.
and stay hydrated.
Man, I used to work construction. It sucks.
Yeah, it
Nothing
does
fun
suck.
about it. Like you can have fun on the job site when you're ribbing somebody, you know what I mean? But it's not fun. You know what I mean?
Yeah, it's exhausting, you know, it's tiring. And you know, working with concrete, it's corrosive material. It dries out your hands no matter how many gloves you put on. You know, it still dries out your it's crazy. But
So what do
yeah,
you
there was
do
this
out there, Ben? You lay in the concrete or
no,
you doing pouring foundations? What do you got?
I'm a construction technician.
Okay.
So I'm certified to go in and test density with a nuclear density gauge. And also I test the integrity of the concrete. So there's different specs for the concrete. And I determine if it passes those specs and if they can place the concrete. So
Nice.
yeah, I've worked on big projects. I worked on the Gordie Howe project, which is the biggest infrastructure project in North America right now. That was fun. Um, yeah, I worked a lot of cool places. Been a lot of cool places.
So the first one that gets the concrete out is you. You test it, and then they can pour it if it's good.
Yeah, yeah. And sometimes they pour it anyways, and you know, it all depends on what they're pouring for. You know, if it's just a tiny little patch in the ground that's a sidewalk, you know, for the city, they might not care. You know, if it's like barely making it or it just under the spec or whatever. But most of the time, it's not for me to decide. I just test it, you know.
Yeah. Do you have to test the dirt as well to see how much compaction there is, or is that not your part? That is?
No, that's part of nuclear density. So I take the nuclear density gauge, which has cesium 127 and americium 235. So, I forget what the isotope of americium, but it has two different radioactive isotopes in it to determine the moisture content and the density content. And you know, there's different scientific tests that you can do. We first established the maximum density of the material by pounding out a mold, and we compare the compaction levels what the gauge picks up. And
Nice.
you know, it's very, very, very scientific, but it's fun. You know, like it's honestly what kind of inspired me to do science and get into some of this stuff. Like, yeah, science is fun. I should probably get back into it.
All right. Well, we're glad you did, man. I love this stuff.
Yeah. So we got 3 rings down. Moving right along. Is there anything that anybody wants to ask or any videos that you guys want us to pull up and chat about while I'm working on the ring here?
No, what do we got here? Old CRT TV. Good source of magnet wire, really. I
Oh.
tear those things apart, man. The first thing I do is I connect the negative to the wire that goes around the tube, right? So that's where it goes. Then you go on the bottom and you connect your positive to the circuit, and you get high voltage sparks in between. So I'm over there turning on and off the TV with the remote, and my sparks going on and off. I love doing that. I should just buy a remote control for my sparks, and I'd be just the happiest guy in the world. You know what I mean? Put a dimmer switch on it. I'd be playing all day.
Dude, you would be, if you were a DJ, you would be timing your sparks to the music.
Oh, dude, don't think that I'm not building that music circuit again. Watch. I'm going to have a music circuit out, and then I won't put up the volume because YouTube won't allow it, but I'm going to rock some AC/DC Thunderstruck on it with some high voltage and let it just fly. You know what I mean? And see what it does.
You know, that's why I like streaming on Twitch. Sometimes I'll stream on Twitch because as long as you don't save the VODs or have the option where it saves your live streams, you can stream whatever you want pretty much, and they don't care. And you can just jam out to whatever. Like if I really want to jam out on live stream to some music and I'm kind of frustrated and I need the music, I will load up Twitch instead, you know, and give but I don't have a lot of audience there, but you know, it's just honestly, it's more for me.
Yeah. Well, you should see me when I'm building my Tesla coil. I I had to use some small wire, right? So I'm over there with 32 gauge wire. I took my wife's eyeglasses she uses to read. Okay. Mind you, my eyes are perfect. It's not that. I put them on. I had them on the tip of my nose, so I look like a really old guy. But I couldn't see where the wires came together at, right? So I'm over there rocking out, you know what I mean, to all kinds of music. And then YouTube decides whoever's playing with that thing or automatic or whatever it does, they changed my music on me. So before I knew it, I was going from heavy metal to just classical music. And I'm wondering what the heck happened here, man. And I'm still trying to wind this thing. And I had to tape it and stop. I go, I'm going to sleep winding this thing doing that. My eyes are getting worse. If you're looking down, it makes you like tired when you're looking through the glasses. It's bad, man. So I had to fix my playlist before I did it again.
So Ian just posted one of the Nunes video, how to make the bundle. I believe that's the PoE vortex coil and how it's made video. If that's it, I'll pull it up. Yeah, let's pull it up because that's a good video, and that'll give you a little bit, anybody who's new to this, more context. Let's see.
Look at that. There you go.
Oh, I found a playlist. We'll play the playlist, and it's got this video in it. So yeah, we'll play some of these videos while I'm doing this, and we'll have some conversation, some commentary. Let's see, pull that up here. Share screen. All right, I'm gonna mute the music because I don't know if it's copyright or not.
Hello everyone, I'm Erica Nunez with OneStopEnergies.com, and today I'm going to show you how to make your own PoE vortex coil.
You know, I watched this video.
For step 1.
So this is a really good video, but there's a couple of areas that it's a little confusing at the end, and I'd like to clarify that too while I have the opportunity here with anybody. Yeah.
We're going to set up 2 hooks 50 feet away from each other.
Thank you for moderating the chat, by the way, Nathan. I appreciate that.
Oh, yeah, no problem. Just trying to help, man. We're all having a good time.
Oh, yeah, this is fun.
Securely tie your wire around the hook.
I wish I could just do this all day, make these coils. Honestly, I'd have fun.
Step 3. Now walk the wire back and forth 24 times.
Yeah, that's about the size of the spool you got, right, Ben?
Yeah. Yep. So they recommend for their coil 50 feet, which turns out to be, I think you need 1,200 feet of coil, something like that. The 50 times 24. But you'll see they really have nothing at the end. I don't know if they cut it off or what, but you know, it looks like they have almost nothing at the end.
Step 5. Snip the wire from the spool and tie it around the bundle. Tightly. Step 6.
And here's a fun, ingenious part that I don't know, I've never seen anybody else do it this method, and it's ingenious. Sorry, I didn't mean to cuss.
Yeah, I saw Bedini do it when he did his coil. He did the same thing.
Oh, and so they might have got it from Bedini.
Yeah, he kind of stood like a little bit away when you first start, and then he walked it as somebody else did it. That way it stays tight the whole time.
Oh, yeah, exactly. And you want to pull it tight because if you don't, you'll end up with a loose spot where it's kind of like all bundled, and then this one little wire is kind of hanging with a loop on the end, like mine. Mine has that at the
That's why he walks it. So he starts off real close, and then he holds the wire as it's spinning in his hand, and then he walks it back so you don't get any of those loops.
So he starts off close and then he walks it back.
And walks it back, yeah, as it starts to wind tight. You got two people to do it. It's easier when you do it by yourself. It's bad.
Yeah, it is easier with two people. But I mean, as long as those wires are, bound together, it should be fine. I want it to be as symmetrical as possible, obviously, but we'll make do with what we can do. Real quick, while I remember, they're twisting, and I don't think they don't mention that there's any. So they're twisting it clockwise, right? But they don't mention if there's any difference if you twist it clockwise or counterclockwise. But I'm going to be continuing doing what they're doing. I'm just, I don't want to stray from what they do. So when I twist it, I'm going to be doing what they do and twisting it clockwise. But
well, if you make another one the same size, do it the other way.
Yeah, see what happens.
And then, yeah, well, what happens when they interact together? That'd be cool too.
Because it's twisting a different way, and I don't know. Maybe it won't make a difference because the interference pattern is interfering with itself, and it's really that matters. I don't know. Honestly, I don't know, but it's fascinating to think about, and I'll definitely try it in the future.
Step 7. Now it's time to twist.
Now, if you do have a second person with you, make sure they are wearing gloves because when you're twisting this is wire and it can cut you. Don't do that. I mean, I guess if you do it real slowly and you're careful, but I don't recommend it. I would wear gloves.
Yeah, she does right on through it. They make it always look so easy.
I know, and you could tell like these guys, they're not professionals, they're amateurs who were put in a position where they had to learn all this stuff. This wasn't their career. They were, I think, Danielle was a model and an actor, and I don't know what Erica did, but they kind of pivoted and started learning all this stuff over the course of like 10, 15 years, and they collaborated with Randy Powell and all sorts of interesting people to teach them this stuff.
Now that we use
you can see their spool here.
The
see, they have a little bit more professional cutout. I'm gonna have to end up just snapping off the ends if I can, or
time to spool it.
You don't have a Dremel?
No, I don't. I mean, I don't have a lot of equipment here. I don't have access to a lot. I have to make do with what I have. A little handsaw. That's what I bought. So if that works,
okay.
It works.
Check it out, Ben. Take some 80 grit sandpaper. Okay, take a block of wood or whatever can fit in there. Like it could be a piece of metal, anything. All you have to do is sand it real quick. Okay, with the 80, then change to a 220, and then it'll polish it out most of the way. Okay. It'll get rid of all the rough edges on the corners when you cut it. Like if you just do it with a like a regular saw blade or something, you always want to hit it with a little bit of sandpaper to smooth it out because that wire has that coating and you don't want to rip that off.
That's a good point. I didn't consider that. Yeah, you said what was the grade? What was the grade of sandpaper? I'm going to write that down in chat real quick so I don't forget.
I used 80 and then 80 220.
And 220. So 80 first, then 220?
Yeah. And 80 is really like heavy grit, so it'll tear down the stuff real quick. 220 is more of a finer one. It'll clean it up. And then you can always, if you're even worried about it past then, throw a couple of layers of duct tape on it. You know what I mean? Just to get another layer of something on there so that it doesn't start to cut everything. That's if you're really worried about it.
No. That's a good idea. And honestly, paying attention to those details is very important to me, at least, because I want this coil to be perfect, as perfect as I can make it. And it's like, it goes back to what I heard Malcolm Bendel say that Martin Fleischmann said to him. He said, Malcolm, spend 6 months preparing the metal and 1 hour to try to get your result. Don't spend, 1 hour making the metal and then 6 months of testing. You have to make the design right, you know, and taking your time with it. And when we wind it, I'm going to take my time with it, as you'll see, you know, be gentle with it. Because before on this coil, I was rushing it a little bit, and you can notice the subtle imperfections, right? You can notice them. I scratched the surface of the enamel on some places, which I was like, oh crap, you know, is that going to affect it? I had to, you know, I actually put electrical tape on that part, that little part that I scratched, because I didn't know if it would affect it or not. But I mean, it seems fine, but this one I want to do right. This, you know, I need to do this coil justice. I need to build one that's perfect. So, and much obliged for the coil frame here, Nathan.
Yeah, don't worry about it, dude.
Yeah, so let's continue on with the video, and we have a whole playlist here that we can, you know, watch and commentate on. I don't think I checked out the other videos.
Step 9. Find a comfortable spot, because now it's time to wind the coil. We will begin by doing the counterclockwise wind first. Up and over.
Hey, Ben, you got a numbering system for that?
When at the starting point, you're just going to skip one above it.
Give me 1 second. What do you mean numbering system? Like how to wire it?
Yeah, how do you keep track of it?
Okay, so it's very simple. I mean, it's harder at the start, or I'm sorry, it's easier at the start and easier at the end, but in the middle it's a little confusing. So what you do is you're going to start out, say you start out in the middle here. Let me get it centered. So you're going to start out in the middle here, and then you're going to well, the ring over here that you would normally be going to. So let's go to this one. So we're going to do it the opposite way. Sorry. It's a little confusing because the left is right and right is left for the camera.
Gotcha.
So say you start out here, you're going to go 1 over and then up. So it's over one. It's always 1 over and then up. 1 over,
Okay.
up at the same time. So it's creating that incline, right? And that's the pattern that you're going to want to find, but follow. But it gets a little confusing when you have to go in the center. So when you start to wind it, though, and you see the other patterns, and you see, oh, that's the one line that fits in between these other two lines, it gets a little easier to see where the pattern is. But when you're first starting out, it's a little confusing. But yeah, it's always 1 over and 1 up. And we're going to start out doing the counterclockwise, which is to the right, and then the interference pattern, which is to the left. So
So you go all one pattern and then you go back on it with all the other pattern?
Yes. So give me 1 second to seal this last seal up, and I'll show you what I mean with the interference pattern.
Oh, that's no problem. I want to ask the question so we can get it out there of what's going on here.
Yes. Well, this is very important. It is something that not a lot of coils do, the interference pattern. So when you come back up to this, so you're winding, and you end up back where you started. Then you're going to bend the wire above and downward this direction and start your clockwise wind on the underneath. So you're probably going to have to flip this over, right? So that's where, and then that's where some of the confusion comes. But here, I'll play the video, and once I play the video, it'll make a lot more sense with the video.
Yeah, no problem. Let me switch it back.
Yeah, they didn't specify a couple of details here that were really important, I think. And that's when you're rushing these videos or you're an amateur, you forget to include stuff, and it's
Well, I asked, they go right to this where they wound the coil already when they were just pulling the wire off.
Mm-hmm. So
Step 10. When you meet the starting point, now you may begin the clockwise wind.
Okay, so you see, right?
You meet the starting.
You see right here, she's underneath the starting point at that little notch right underneath it, making the bend on top of it. So you make the bend. So originally you started out with this and you went this way. You went upwards to the right. Now you're going downwards to the right. But when you flip the donut, it's going to be downwards to the left, right? Sorry, I didn't mean to say right. It gets confusing.
Well, it's not a problem. It's just learning the flow of this thing.
Yeah, no, I get excited about it because it's really exciting, but at the same time, it's a little frustrating because I know I was there with certain people where certain people are now trying to understand what exactly do they mean. And there's a couple of spots at the end of this video hooking it up where I was like, wait, what? And I really had to, you know, look at what they were doing and in the full context of all their videos to really understand, you know, how to connect this thing in a way that actually produces some over unity.
Point. Now you may begin the clockwise wind. Just note that after the very first loop, you will be going directly under the starting point.
So hold on, Ben. I got a question for you.
Mm-hmm.
So these aren't two separate coils; they're one winding all together.
Yes.
Okay.
But the way you hook the wires up does essentially produce two coils. They're just wound together in one bundle. So what you're going to end up doing is you're separating these 24 wires into two channels of 12 and 12, and you're putting each 12 in series. So it's one really, really long, or it's two really, really long wires. So essentially it is a 1-to-1 ratio coil. It's a 1-to-1 transformer is what it is.
Okay.
Yeah, and that's a really good question because not a lot of people realize that it is actually the way you hook it up. It could be 3 coils. You know, you could have 3 channels, and a lot of people do experiment with 3 channels, and that's something that I'm going to be doing in the future.
Well, I originally thought you did one wind in one direction, and that was from start to finish, and that's it. And then you started to wind a whole new direction with a whole nother wire. You know what I mean?
It's a common mistake.
Finish.
Yeah, it's, I mean, you would think it, and it is a common mistake, but the thing is, you want the energy to travel in one way and then the other way in the same, you know, I guess that's the idea. So as long as, and it doesn't, and they said, the Nunez say it doesn't matter where it starts and where it finishes, as long as it's counter rotational, you have those 2 vortices. Oh, one thing real quick, right here is what we're going to be doing, and they didn't do in this video, is when you start the interference pattern, because the coil frame sticks pretty well for the first wind, but when you start the interference pattern, sometimes the slots can get a little crowded. This is a little bit bigger, so it might not have an issue, but I'm still going to reinforce the second interference wind with zip ties. So what we're going to do is at each intersection point where the wire intersects with itself, like right here, we're just put a zip tie there, not too tight, and then reinforce it so it stays in place. And that's something they didn't do it. Yeah. So it's going to help us out with if you have to transport it or ship it anywhere, it's just going to help keep that wire in place.
Okay.
To take it, step 11. Now that the winding is complete.
Yeah, she straight up just went from winding out back to being done real quick.
Yeah, you could tell it wasn't a professionally done video, you know, and not everybody's a video producer. I understand, you know, and even I miss things that I intend to put in my videos, and I make mistakes.
It's not that. What I would just say, it's the confusing part that they skipped over a little bit. They should have, you know, just gone to that a little bit more. That's my opinion. But I appreciate the fact that they're showing it. It's just for somebody who hasn't done it before, you need more information right there.
Right. Well, the thing is, and Bernie could probably have more, shed more light on this, but I have a feeling they did in other videos that actually were taken down off of YouTube, because they had hundreds of videos where they had different demonstrations and tutorials like this. This is like the one that people, honestly, I guess was the most popular, and people just grabbed it and downloaded it and reposted it on their own channel. And that's how that's my theory on how a couple of their videos survived. But they might, maybe they had more detailed information elsewhere. It's we have the answer now. So, and basically what she's doing is she's
she's burning off the enamel, so it makes it easier to sand, because if you don't burn it off first, you're going to sit there, you know, like for an hour trying to sand it off if you don't have a proper.
You could buy a tool that goes over top of it, which I need to buy. I use a razor blade to scrape it off, but even that doesn't get it all. So you're better off with the burning it, to be honest with you, until you can get that stripping tool.
And the thing is, I do recommend anybody trying this to use the burning method first before you grind it, just because grinding it puts a strain on the tips of the leads. You know, you don't want to add micro fractures there and damage your lead. You know, you want to, you know, just grind it off enough to scrape that enamel, but you don't want to damage the wire. And when you don't have a, you know, a method of burning it off fast and then grinding it, it's just, you know, you're going to sit there and grind it, you know, and break those tips.
The wire.
So you see how it flashes? There's a little flash. That's it. When I burn them, I wait for that flash and that's it. You know, I don't want to overburn it, but you know, when you just take it to it and you look for that flash of that's the enamel kind of like disintegrating, I guess.
We are melting off the enamel, so when it's time to solder, it's easier to make the connections. Step 12. Now it's time to sand the ends and remove the burnt enamel.
Man, that's pretty quick.
Yeah, it gets off pretty quick when you burn it.
You ought to invest in one of those little Dremels there, Ben.
Take your alligator clip and connect.
Oh, I have
it to
one.
Any of
I asked you if you had one. You said no.
Oh,
Right
maybe I didn't
now,
hear what you said. My bad.
we have 48 wires.
Well, yeah, cutting that PVC pipe would be a lot easier with a Dremel.
So being that it made the
Yeah, no, I
connection,
do
this
have a
is the
Dremel.
finish.
Yeah, we can use
When
that.
This is the start. Take the finished wire and connect it to any other wire.
So this is yeah, I'll grab it 1 second to show you, but this is where we're hooking our 2 channels up in series. So what we're going to do is we're going to take one wire from one end, and we're going to take another wire from the other end, and we're going to test them with our multimeter until we find the one that is the same wire, essentially. And then when we find the same wire on both ends, we're going to take one end, drop it, and then look for any other wire and then connect it, right? So we're connecting 2 wires in series, and we're keeping one in one hand and connecting, you know, finding the lead and then connecting it. So we're going to be repeating that process is
So
holding
it's
it.
got to be the same wire that loops around and then comes back to the other end. Okay,
yes.
So you're going to basically put your multimeter on conductivity and let it beep, so that when you touch the 2 ends together in the right, it'll beep and tell you hello.
Yes. So there's a method, and then they don't really explain it too well, but that's the method here. We're holding it. Oh.
And you're going to repeat this process.
It's a good thing that's dry. We're going to be holding it in one hand and then looking for the lead in the other hand. So we're not really going to, so. And we're going to do that for 2 channels, 12 times.
With channel A,
so that channel has 12 wires in series, and the 2 wires are not actually connected. So it's 11 wires connected, and then the last 2 are open as your leads to attach to a load or whatever.
Gotcha.
Makes it 1 wire, and I'm going to proceed to doing the same thing I did with these 11 connections on channel B. That sound is channel B completed. Now for step 14, we're going to solder all the connections.
So the reason why I didn't solder my connections and I used tape instead is because I wanted to test and see if asymmetrical coil would do anything, which it doesn't, or different configurations. But honestly, I do recommend testing. Be careful, put some tape on it, test it first to make sure it works, and then solder the leads. Make sure it works, and then you have it right, and then solder the leads so you can make a good finish for the product.
For step 15, get electrical tape and put it around the ends of the wire that was soldered to avoid the connections touching. Now that you have successfully finished wiring and connecting your PoE vortex coil, it is time for testing. We're going to take channel A and connect it to the amplifier, and channel B and connect it to the amplifier. Now for the last two wires that are remaining, they are going to be connected to the 192 LED panel.
Oh.
Yep. So this is using the open circuit method. I'll grab the chart here in a second for everybody to see.
Turn it on, and voila. Thank you very much for your time. This is Erica Nunez with one.
So this is the circuit that they're using in this video.
Sorry, give me 1 second. There you go. Go ahead.
There we go. All right, awesome. So this is the circuit that they're using in this video. It's the Nunez method open circuit. And what they're doing is they're crisscrossing the ends of coil A and coil B. So as you can see, the input of coil A is from the source, the tone gen, and the output goes to the positive of the load. But the input of B is going to the negative of the load, and the output of B is going to the source. So it's like crisscross almost. It's very, and I don't know. It's not something you would traditionally be taught to hook up in that way, but it works, and I've proven that it works.
Very good.
Mm-hmm. All right, yeah, let's put the next video on. Let's finish this coil, and Nathan, if you have anything for me to, if you have any videos or anything for us to discuss, feel free. We'll consider this like an open mic.
Oh yeah. So Ben, how far you got it glued so far? You want to show us?
Yeah.
Let me put you back on the solo layout here, and just want to see where you're at.
So we have 3, 4, 5, 6, 7 rings. Oh, 7 small rings done. We need 1, 2, 3, 4 to go.
Hey, Ben, you got your magnet over there, the ball magnet? I want to see it in the center of that thing,
Right.
just so we can take a look at the...
Oh, the neodymium? Yeah.
Yeah, maybe with a little cup or something, we can kind of see where you're going to go with testing on it. That'd be really cool. I'm kind of excited. This thing's a lot bigger, so yeah, there's a Neo. Here we go. Now put it right in the center of the coil. See if it fits.
Yeah.
Oh, we got plenty of room there.
Plenty of room.
Oh yeah, that'd be
If
cool.
this thing doesn't, if this thing doesn't synchronize, you know what? I have a feeling that this bigger geometry might allow it to synchronize at lower input levels.
Well, yeah, because I want to see it right in the center of that thing. You weren't able to get it there before, but I've seen a lot of videos with it there in the center, so that'd be pretty cool right there.
Yeah, floating, exactly, and we have more room to do that too. Exactly. No, that's good. You know what? I think that coil is honestly a little bit too small to float this neodymium sphere, because this is a thick baby. You know, this is a big baby boy. But this, I think this is perfect. We'll be able to get this sucker to float, or if it doesn't float, it's going to fly through my ceiling. I'm going to lose my deposit.
Or it'll just spin really fast. I mean, I want to see it. Definitely have to mark it.
Yeah, no, I think it's going to either spin real fast or it'll float. I think we'll get it to float. I have a feeling it'll levitate. That's a good point. I didn't think about that.
Yeah, we'll have to find some tests for Ben to do that's not ordinary. You know what I mean? Kind of throw everything at the wall and see what sticks, kind of thing.
Yeah, exactly. I can't think of everything. You guys got to help me.
I'd like to see some iron ferrite in a jar of water or electrolyte, right? No, there you go. There's a Dremel.
Yeah.
So Ben, take some iron ferrite, right? So you can see where the magnetic flow goes. Put it in a solution of like electrolytes or something, and then spin it, and maybe put the magnet on the bottom. Let's see where they go. You know what I mean? If they come off the magnet, you know what I mean? Maybe you put the magnet in another container underneath. You know what I mean? Kind of play with it and see what it does. Because, you know, anything like a ferrofluid or anything that's magnetic, that'd be awesome.
Yeah. Ferrofluid is definitely something on my list. And the thing is, if you watch the conference, the Breakthrough Energy Movement conference that the Nunez has put together, the presentation, I think it was like back in 2014 or something. But they specifically say, because somebody asked them, you know, what happens if you put ferrofluid in the middle? And Daniel Nunez said nothing happens to the ferrofluid, but he didn't find a North Pole. We did in the coil that I have. So either maybe my theory is that the subtle imperfections in my coil might be kind of making the North Pole less pinched and more visible.
Gotcha.
Yeah, it might have some effect. I don't know.
Well, you know what? Wind the coil and braid it like Gerald does. So he creates two coils, right? And then he like twists them and braids them. So what it'll give you is it'll give you two coil directions. And then when you run your electricity through it in the center, it'll also change your Rodin coil at that point, and it'll give you a true north and south easily for any reason. You know what I mean? But that'd be really cool.
Yeah, the ideal situation is to have full control over the North and South Pole, right? You know, you don't want to have a situation where you're trying to get the North Pole and you can't get it, you know, or manipulate it. You want to be able to manipulate both of them. So that's my idea here, because that would make it a really good all-in-one unit, you know, for, you know, different applications.
You know what? You should show the testing and the good and the bad and the ugly. You know what I mean? And see what really these things do.
Oh, that's what. Yeah, and that's kind of like what I've been trying to do. And you know, you guys have seen it. You know, I've blown up capacitors. I blew up my stereo amp receiver on live. You know, like I'm trying to, you know, do more and more testing and trying to push it a little bit as safely as I can. You know, and that's what a lot of people they come in and they don't really understand is. I want to make sure I have a safe environment to do some of these experiments you guys are suggesting. And it's not like I don't want to do them or I just can't. You know, I have them on my list. It's a slow process. You know, I'm in a 1-bedroom apartment. I want to make sure I have all the, you know, I got my girlfriend here. I don't want to be in a situation where, you know, she's waking up to a fire or something. You know?
Oh, man. Well, I don't think you work with that high of electricity.
No.
Yeah, I'd send your eyebrows. You come over to my garage. We'd be lighting it up. We get a tan. We get everything. You know what I mean?
I'll light my cigarette with your Tesla coil.
Crazy.
But I'm going to take a quick bathroom break. Nathan, if
go
you
for it.
have anything you want to share or talk about, feel free. I'm going to, I'll be right back.
Yeah, well, let's look it up, man. I'll go through my list here. Let's do a little high voltage while he's gone. We'll just blast it out. That's what I always do.
Ooh, I might not leave now.
Well, I don't think you work with that high of electricity.
But I'm going to take a quick bathroom break. Nathan, if you have anything you want to share or talk about, feel free. I'm going to,
Let's look it up, man. Yeah, let me see. What do we got here? We got to have something good here. Oh, let's take a look at this one. I'll share this one. I do a lot of high voltage, guys. So let's see. Share it. There we go. When you want to let loose, it's time to just let it all hang out. So what do I do for fun here on this channel? Well, I light things up. That's what I like to do. Not with does here. Well, these are not just for fun. You can see the two half moons in there as it lights up.
No more voltage than meet in the center. Just cool. That's only three. That's all it took. Anyway, that's it.
So yeah, it's just 3 AA batteries and you get all that electricity out of it. That was really cool. Let's see. Do I set it on fire next? Yeah, I do. Okay, hold on.
Then run a flyback spark right through it. The effect was really awesome. I like the fact that this thing started out really calm and then it just hit and then it hit again and it just lit up the whole room, man. It looked cool and it sounded just gnarly.
Yeah. It's always fun, man. Always fun. Here's one I did. Let's see where we have it. Let's see if I light up a plasma bridge here for you. Oh, there we go. Don't try this at home.
And to ride the lightning.
So you might ask how I set this. So
the voltage is real thin. It doesn't have a whole lot of white in it. Perfect for making plasma that sprays out in that cool looking effect. I wouldn't recommend you do this at home unless you want to ride the lightning.
So you might ask how I set this stuff up. These things are generally pretty simple. If you look at this, and I'll show you a good picture of it, there's a positive and negative on it. All you have to do is line those up with your battery. I put these little ends on here. I'll show you a better picture of that. And it's a simple wrap around your DC coil here. Probably had a little more zap in it. Anyway, right here, the positive and negative. I've had these things where the amps are so high on this side, this little bracket here, it just burns right off. It unsolders itself, and then I had to solder directly to the board itself. So keep that in mind. Now on your negative, it's just the one that sparks the best. I'll show you a picture of that. It's actually pretty cool when you do it. It's a little fun adventure just to have, because maybe you just want to go out and spark something. I do that. Matter of fact, I do it a lot. But anyway, I'll show this better for you, but this is one of the setups I use. This is one of my voltage coils. So you're basically going to see this one with the, you're going to see it with the battery right here. So that right there is what's going to create your pink plasma.
All you need to do is get your ZVS set up here with your flyback. Okay, and all you're going to do is you're going to put, this is an aluminum ring. You can use steel, okay, it won't matter, or copper. And then you're going to take a hole saw and your drill. And all you're going to do is you'll end up centering up the drill. Make sure you tape off the light here, okay, so you don't get that in the background because it makes a very bad image. Then you're going to take your wire here. Mine's all kind of funky hooked up to this big old cord that comes across here. And all you're going to do is you got your negative over here. This will be your positive. As you hit the drill, just place that on there as you're holding the drill. Now, pull the drill out before you stop it. because you'll get a little bit of a shock depending on how much your ZVS is going, because there's a lot of static going on. Put that right there, make a ring of fire, and I'll show you how it looks. So what I want you to notice right here is you see that the power pack was hooked up earlier, and it puts out a lot of amps. As you see in the plasma here, there's a lot of white, and yes, it does go into pink, but all that white is the amps in the plasma. That's why this one works the way it does. Again, distance, we are probably about an inch and a quarter on this one, because we're not looking for that big giant plasma effect. We're looking for like amp in plasma effect. This one right here is the one I use to create most voltage projects. The actual flyback in here is a little different than the other one. So I'm getting a much thinner spark, which is exactly what you're looking for. The thick ones with a lot of white in them have way too many amps. So this is the one I would use the power pack on. Again, I'll show you a better picture of this. As you can see, there's no piece right here. Again, I had to solder it to the back because I overamped it with a different power source than I usually use. But this is the coil that I go to right here. Again, here's the power pack that I use here. And just as a quick understanding, I'll show you this a little better. Oh, anytime you use one of these right here, just remember this right here with the shielding on it of the plastic is your positive. Anything right here with just the metal, it forms around the whole thing. You got to pull it to one side. I solder mine off. That's your negative. One of my favorite things to do with plasma is to connect it with these items here. Now, this is just a solid piece of aluminum all the way through. These right here are just saw blades. They were once one blade, pretty big, just like that, used for cutting tree limbs and stuff. Anyway, what you do is you connect the positive here or the negative. Doesn't really matter. They're both positive. So just hook the one you think is positive here, the one you think is negative here. Right about here, you're about 1.5 inches off. That's about exactly where you need to be. Sometimes a little more, sometimes a little less, but that's where you need to be. And that'll create that nice plasma bridge you see right in between it. Now, you want to get a little more advanced. You take this and this and you set it up in this configuration here. Now, what are you doing? This has to be connected to this one. So these two are connected on the same line. This is connected on the opposite. So if you said these two were negative, this would be the positive wire. Again, distance is important. Now, you may think, well, you're using two, so you need to bring in the distance a little bit. And the answer is no, not at this level. Just right here. This is exactly what you need. So that'll get you this nice plasma look here. One thing to remember is the sound you want to hear. When you hit that sound, you know you're at the correct distance. Maybe you want to do it in saw blades. The key here is metal, no paint. This is a used saw blade, plenty of metal on the ends here. So what do you want to do? Same thing. If you connect it with this right here and straight, you're only going to get the one where the distance matches right here. So obviously that's just this. What do you have to do? You have to bend this around the curve to match the saw blade. Now, can you use two saw blades sitting on top of each other? The answer is yes. And all you have to do is you line up the two saw blades here. Again, two, line them up. Again, put this piece over here, and it'll give you the same plasma look. Everything's about a big size and a small size, no matter how you do it. One has to have more mass in metal. That's the key here. And no paint. If you use something that has paint, it's not going to give you that same plasma look you're looking for. It'll actually maybe just spark over once or twice if you're lucky. Or it might just do nothing. The key is no paint. Has to be bare metal.
That's how you do it. This is what the saw blades look like when you connect it to the rod now. And you can see on here, I bent the rod. And I just want you to look at each one of the little ends of the saw blade here, the little points. They actually make the plasma come right off of it. And that's what you're looking for. A couple of things here. If I just wanted to use a hole saw and a ring, could I do it? Sharp edges, again, metal. Everything depends on distance. As you can see here, the aluminum ring is about 1 3/4 inches or so away from the bottom hole saw blade. I didn't show the connections in this one, but obviously the ring is positive, and on the bottom, the hole saw blade is negative. From the side, this just looks like a bowl. From the top, it kind of looks like a vortex. Just to show you, you can use just about anything for one of these projects. This right here is my big speed square. This right here is the same saw blade you saw earlier. Now, I can put this on this side right here and create plasma in between it. Why? Because this has more metal in it than this. And again, sharp edges and no paint. This right here makes this effect right here look cool, just like this.
Wow, that's awesome.
This right here is a pretty cool effect. What's going on? I have positive on one side, negative on the other, and all I'm doing is converting small to big, and it's sending ion wind down to the other plate. Now, if I pulled it back just a bit, it would just create charge on the disc. This way it converts it over. Just so you're aware, every time it sparks over, it loses charge on the plates, and it has to start over. I just wanted to show you guys this build real quick. This is a... Hey, Ben, you're back. Oh, now you're gone again. Okay.
Hello? Oh, yes. What's up? I had to go spark one.
No, that's fine. I wanted to check on you when you came back before I played anymore. We good to play it, or you got something to show?
No, I don't have anything to show right now. You can continue. I might find another video in a minute, but yeah, this is good. I like it.
1000-watt ZVS. This is a DC flyback transformer, and this is a second DC flyback transformer. As you can see, we have 7 wraps on this and 7 on this one. Now the one that goes over top, I put it on this left one here, output B. The one that goes under it goes to output A, which is on this side. Okay. And this right here connects here, and it connects here. This top one here connects here and here. This is run really simple. The hot wire that comes out the red one right there, it connects over here to the ground that goes into this one. Then we have the hot wire that comes out here. Okay, and then that one goes right here to the ground, and they spark across here. Now, let's go ahead and take a look real quick. This right here is the schematic for it. And as you can see, we have a power pack on this one, 19 volts, 2.37 amps. Goes to a ZVS. Pretty simple, plus and minus are shown. All right, guys, let's just skip to the good part. All right, now we turn off the light. Let's go ahead and take a look at this. Look at the ends. You can already see them lighting up right there. Let's bring it a little closer. And yes, I do have fireworks going on behind me on that one. See it coming together? Let's see. Right there, that's what I want. See that? That purple? Perfect. That's why you build them in like this, with 2 of them together, because you want that right there. And yeah, I do need to replace that that transformer. It's bad. But you can see the spark. Get closer, it sparks out. A little further, you get the ion wind. Exactly what we're looking for is a perfect setup for that. All right, let me
turn this off without trying to zap the living daylights out of myself. All right. So you can get a look at what we're doing here. Here's our negative. Anywhere on the bottom here, they're all connected all together on the bottom. All the wires are connected into one. So you can just hit one on the negative there. And then let's go ahead and see if we can't move some stuff out of the way. I'm just going to set this right here. Get this wire out of our way. Okay. There we go. Let's just make sure the circuit works. And then we'll turn off the lights again. There we go. I can hear it. All right. I'm going to go turn off the lights real quick and you can see it. Let's see. Probably have to do that. There we go. You can see it right in there now. Look at that. Now this one's kind of beat up. I've been using it a lot. You can see every point where there's a sharp point, it breaks out. So there's ion wind coming off of it right now. So this is what that circuit could do, and I got a busted transformer that's starting to burn out on me, and it's still producing this. So it's a pretty good circuit if you want to run it. I have the STLs for this right here, or the 3D printed files where you can make your own online. I'll go ahead and put the link in the description for you. But I just wanted to show you this. It's a pretty cool setup, and it makes some pretty awesome ion wind. I want to show you guys this. Look, this is the top of the thruster at night. You see all those little lights, or like, I don't know what to call them. Everywhere that you see them is where my razor blade went over the magnet wire to make it bare. So you can see just the total amount of ions that are pulling from there only. The rest of the magnet wire doesn't do anything. It's just this little bunch, okay? So if I probably add more, okay, I can get a little bit more, but it doesn't add in the amount that it comes out, right? So we're getting what? Like 2.3 ms out of a regular thruster. But by adding a second wire, and you can see it in there right there, so it's 2 right there, and then it goes down to 1 bar in the middle. It did add volume to the total amount of air coming out. So we added more air coming out, okay, which will eventually give us more thrust. But, okay, we didn't change the amount coming out. So I hope you understand that. Just give you a better look. Make a really nice light show if you're watching it. You can see just a total cloud there now. It used to be real thin. I didn't show it the other one at night. But anyway, it comes over real nice. Just thought it'd be cool to show you that. It's a really, really neat thing to see at night.
Yeah, but by the way, guys, I got those STLs are on Thingiverse. If you just look it up, so it should say ion thruster or plasma thruster or something like that. But yeah, you could build it yourself at home. Just take that flyback like I showed earlier. I used 2 in series, get that sucker real thin. Test it out just the way I did, man. It comes out beautiful. Just make sure you have ventilation. So if you run it for like 2 or 3 minutes, make sure you open up your garage and ventilate it. Never run it in your house. Always you have to have it dark so that you can see it. But, you know, a little exhaust fan or something like that would be awesome. Hey, Ben, where you at with your coil? You got a couple more in?
Just one more to go, and that's all we have left for the coil frame, my friends. Ladies and gentlemen, we are at the end of the stretch here. For coil frame, at least.
Right on. How long did it take for all that to dry, Ben, before you start working with it?
The bottle
or the glue recommends 6 hours, but I recommend a full 24 hours just to
Full
be
day?
sure. Yeah, there might be differences in moisture content in your atmosphere, and that might differentiate the cure time. And I don't know. I just like to be safe. Always safe than sorry. So I give it 24 hours, but we're going to give it more than that, obviously, because we're not going to be ready for at least another week or so, depending on when I get the wire.
Right on.
I do have a smaller spool, so we can kind of see what it will look like,
Well, make sure when you do the rope, you tape it and put it up on video so that we can see it. So that we take Ian's theory and put it together and show it what it looks like.
Actually, I can do that on this live stream, because what I'm going to do is not rope. I'm just going to I'll do it with the wire. I have the same wire. I just have a smaller spool. So what I'm going to do is, I'll measure it with that, and we'll just, take that and times it by 24, right? That should give us our answer.
Well, even better. Let's see it. You know what I mean? Obviously, when you're done and you can maneuver it, obviously.
Yeah, and that'll be a good. No, this is good, because then I get the opportunity to show you guys, before our class, so you're ready, how to actually wind it, and we'll do one wind with it. It'll be real easy. I promise everybody it'll be easy and painless. But yeah, we'll give this a few minutes to set. Yeah, because it should be fine. I'm just going to be really delicate with it. That's all.
No, do what you're comfortable with. I'd hate to see you ruin your project. So
worst case scenario, I just have to glue it over again. So.
By the way, just so you guys know, if it's metal and it's in my garage, it's not safe. It's going to get high voltage through it.
Yeah, and your hair might stand up.
Oh, well, you see, dude, I use my speed square. Whatever comes to mind, whatever saw blade's laying around, you better watch twice, because I'm going to take it and use it, and I'm going to put it in my experiment and see what it does. So,
yeah,
dude,
if
I cut up.
A toupee, don't go into his workshop. It'll be whoop.
I cut up 3 saw blades that were for my table saw over here, and I used those in that axe I was doing, man. It was just amazing. Both sides lit up on it, you know what I mean, with plasma. And then the center went like this, okay? So I had another plasma thing going up just like that. I did a Jacob's ladder out of the top, and it had a big skull on the front. Man, that thing was cool. So, yeah, they wouldn't let me go out and LARP with that, that's for sure. Sending me home. Old man's over there trying to burn everything down or sit there with some plasma. Yeah. Hey, Sean, what's up, man? We were just building some plasma while Ben's over here putting his coil together. So he's putting the last winding in now. Go ahead. I'm going to play a little more plasma there for you, Ben, while you're doing that.
Yeah. Sounds zen to me.
Well,
meters per second is about what I got. And on this one,
okay, it stopped.
It's not hooked up in double form. It's just a single one blowing at this time. And as you can see right here, turn on one last time. 2.4, it jumps up to 2.9, but it's more of an anomaly than the 2.4 consistently coming out of it. But once in a while it gets there. Here are some high voltage experiments that I did. Here's the first one, voltage walking.
Told you, no stall safe.
Oh,
not even my wires are safe, man. I'm gonna set them on fire. What?
It's like dancing.
Yeah, like a little running man.
Yeah.
Here's the second experiment. I call it pins and needles.
Hey, don't walk into the garage, everybody. He's sparking one up.
Yeah, you know, it only goes to one at a time. It never goes to all of them. I was kind of hoping for all of them to hit at once, but they wouldn't do it.
Maybe if you have multiple.
This is the third experiment. We've all seen voltage on a round magnet. This is what it looks like on a rotating magnet.
definitely need to get a slow-mo camera for this, Nathan. No, I'm serious. That would be. Oh my god. I
That
think we're
magnet
missing
Just
died
in
on
a
case
me.
you were
here.
wondering, yes, I did demagnetize those magnets, putting them in the high voltage field. Those went in the trash.
I
Well,
think
if you
we're missing
want to
a
find
lot by not
flybacks and
seeing
you don't
those
know where to
small
look,
details.
this is a CRT TV, or otherwise known as a tube
Did you try
TV.
it?
And yes, there's a flyback in here. But the question is, do we have to rip it out, or can we just use it as is?
Really? Ooh.
This is a spark gap for a CRT TV, or basically a tubed TV. It's a 27-inch TV. The positive gets connected to the flyback transformer. The negative gets attached to the strap on the TV. It also has a connection to the motherboard, which I'll show you later.
So that strap is a
Yes,
ground.
I
I'm
do
assuming?
have to clean it. That's probably just all the garbage on there smoking off. No, it was something else smoking. The spark gap on
That's
this gets
so
pretty
cool.
big,
Look at
but you
that.
have to start it real small.
Hold
As
on.
you can see, we're about
back
1
there,
inch away
Nathan,
when
for a
we
second.
start. We get up to about 3 3/4 inches on this.
That's
I'm sorry.
that's
What's that?
no. I was gonna say, go back for a second on that spark gap. That doesn't look like a normal spark gap, does it?
Oh, look cool, doesn't
Like
it?
at least the plasma discharge doesn't look normal. Like it looks like it's. Have you ever seen the Harry Potter scene where they collide their wands and it looks like one's pushing against the other? That's what that looks like.
Let me find it.
Yeah, it's like right after that part.
Okay, we'll hit play.
The flyback in here.
Yeah.
But the question is, do we have to rip it out, or can we just use it as is?
This is a spark
Right
gap
there.
for a
Look.
CRT TV, or
It looks like it's
basically a
fighting
tube
the other side.
TV. It's a 20. Yeah, that looks really cool.
That is insane. Wow.
Yeah,
No, that's-
all voltage dances a little bit with these.
I don't know. Maybe I'm just seeing things, but I don't know. It looks different. It's cool. It's really good work. I love it. Oh, look at that. Jacob's ladder. Oh,
It's all twisted up like DNA.
yeah. Like it should be. Like it's going to travel that way probably. Or more naturally that way. I think if you twist it more, you might be able to get. It looks like it. I don't know. Like it.
I love how it rides up, man. This is a bit longer. I shortened it, that thing a little bit to do it. I did it again, but
There you go. Oh wow. That's cool.
yeah, simple stuff.
You-
The old man Bill does in his garage when nobody's looking. I'll tell you, nothing's safe. If it's metal, I'm lighting it up.
We're gonna put one of those. Make like an artistic piece out of it to put it behind you on camera. You know, like put like a little glass display around it. You know, just have it sparking in the background while you're on camera. That'd be sweet.
Yeah. Let's see what else we got on here. I got some more stuff I probably lit up. Oh, this next one's cool. We're gonna listen for some sound. I'll turn it back up.
Things.
Yeah.
So I just have a coil here, and I want to put a spark cap through it. And well, let's just see what it sounds like.
So originally I was going to build this thing as an atmosphere motor, and well, I failed. So I decided to just... Okay, hold on. With this one, you ever want to see the stages of plasma, okay? And you want to know where it goes from. I'll just tell you the backstory real quick, okay? I was trying to build a Corona motor, and I didn't listen to everybody else and, smooth the edges, stuff like that. And I put it in the wrong direction. Total nightmare, right? Totally messed it up. My fault, okay? But when the thing starts burning the plastic, you'll start seeing it'll go from purple, where you get the ion, you know what I mean? Then it'll start going into different colors as it starts getting hot. you'll start to see the white and the yellow, and it'll light it up. Okay, so I'll just restart it real quick and let you watch it.
That means if we actually build a lightsaber, Nathan, the yellow is going to be the strongest. The yellow and the white.
Yeah.
Oh, I got excited. I almost trashed my frame here. I got so excited about that.
So originally I was going to build this thing as an atmosphere motor, and well, I failed. So I decided to just hit it with a lot of high voltage and see what it looked like. And well, you could see that it pretty much is starting on fire. Yeah, that was fun. You know, you just can't win them all.
No, I don't think I ever win them all with this stuff.
Most people see this experiment as a can being moved by static electricity. But did you know high voltage can do the exact same thing? Here is a static electricity experiment. It just works on a simple principle.
My bad.
Take the cloth, rub the rod, and it'll move the can. Static electricity does the rest. Now let's use some high voltage, and let's see if we can't get the can to move again.
Hold on, Ben. Let me just rewind it a little bit.
Static electricity does the rest.
So you see static electricity doing it,
Now
right?
let's use some high voltage, and let's see if we can't get the can to move again. As you can see, both effects have worked. Why? Because we're polarizing the can.
Oh,
As you can see here, I sanded the can down. Why? Because it reacts better to the high voltage when it has metal to metal. Just to show you that the high voltage is actually on and it's working well, let's go ahead and turn off the lights and see if we can't get a little plasma now that the can is sanded a little bit.
I can't immediately move, by the way.
Now, is it an attraction or a repulsion force that's happening?
As you can see, the high voltage works just fine.
So, good thing you asked. When you polarize the can with a PVC pipe, it's attraction. When I do it with the high voltage, it's repulsion. So, it's more of an eddy current in it that forces it away because of the magnetism. So let's hit play.
Fine. We get a great plasma out of it. And yes, I do need some new wires. They have cut open with the high voltage experiments and they seem to blast plasma everywhere. I'll tell you what, though, it does make a cool look with that wire being messed up. It actually shows you just a stream of plasma coming off that thing.
Of course, the wires are busted.
For those of you who are doing high voltage experiments, you should really understand the simple fact. When you thin out the voltage and remove the amps, it acts just like static electricity, and it polarizes things. In this experiment, we just use a simple can, whether it be from static electricity or from the high voltage.
Well, let's go forward a bit.
As we put in these
I'll
last
show you how to build a
AC
high voltage
flyback.
multiplier
You can see it goes over.
with an AC flyback in it. Let's see what it does. So we got it connected.
This thing on, let's see what we can do.
Dang. That is a nice lightning arc.
Yeah.
It looks like lightning. Wow.
Like every
As you can
kind of
see,
different
we all
spark
work.
gap or
It
arc
looks
looks
good.
different.
I like it.
Thing's a beast, isn't it?
Yeah.
That was
I
just
like
one
the way
voltage
it,
multiplier. I got 2 set up. I'm gonna try here in the next couple of days.
like
So
I
I
know
got
some people prefer the purple, and purple looks nice, don't get me wrong, but that clean, like blue, crisp lightning effect. Ooh, I love it. Go spark one up right now.
yeah. Watch this.
Oh, that's so cool. Hey, we're inventing a new way to make your popcorn, everybody. a cooler way, but a more dangerous way. So don't try it.
Yeah, bro. This stuff's so cool. I do it at night, and you know what I mean. You can see the lightning during the day, but this part, you know what I mean, with the purple lights up
Right.
too, like that.
You can see, yeah, you can see like the fog of it, the fog of the purple too. The discharge. What is that considered? Like I know there's the discharge, which is like the kind of like the arcs, and then the fog.
Yeah, it's like an ion.
Like a gas, right?
Yeah.
Yeah.
Well, it's not so much a gas, still a voltage, but you're getting there.
But it is doing something to the atmosphere, like, and you could see like it's a gaseous. Yeah, it's like almost like a force field.
Yeah, it's really cool, huh? So just so you know, if you hold it off a little bit more, it'll start charging things up. When it doesn't create the plasma look, and you keep it a little further away, you start putting a charge on things. Okay, so if you're ever wondering when you want to make charge, and you put it on a plate here and a plate here and a pole in the center, and you put paper in there like a little paper UFO, it'll create a heavy static charge based on the distance. You put it closer, you're going to get the plasma breakout. You put it further away, you're going to get a static charge, and it just creates massive amount of charge on it.
Right, because there's less space for the plasma to arc like that.
Because you're not wasting it. You're not using it. Right here, as soon as it sparks,
you got it close.
You're using it. And the other way, it just builds up and builds up.
No, that makes sense. It's sparking, it's discharging, it's wasting energy. And you can visually see it in the form of that light, the lightning effect. It's really cool.
Yeah, you wonder why. We'll talk about the static electricity on the UFO thing. Well, I've had plenty of experience in knowing what it's not. You know what I mean? Then I've plenty of experience knowing what it was and using it.
And that's so cool that we can actually, like, most people are actually, you know, trying to build these systems or trying to build cool systems that are practical and aiming for the lightning effect. But that's the opposite of what you want, you know, that you want to minimize that in order to increase the efficiency of it.
But by the way, Sean, nothing's grounded. This is just straight positive and negative out of the coil. The top plate was actually built like a capacitor at one time. So it's got like 4 different plates in there. And on each plate, there's a piece of aluminum foil on each one. And they're stacked. So you get a little bit of extra coming out of it.
Oh, you know what? I have my microphone backwards. I'm sorry, everybody. That's probably better.
Yeah, I have too much fun in my garage. That's for sure.
Hey, it looks like a lot of fun. I would probably have a lot of fun in your garage too. Probably too much fun. Probably get myself into trouble.
Yeah, let's see what else. I don't know what else I blew up on this one. Oh. They have sounds on this one too, if you want to hear it. Let's see.
Alien sound again.
Oh, I hear that screeching.
Beautiful plasma arrays are easy to build, but how do you get this effect and avoid this effect? Yeah, just sparking over like crazy. And then what's going on during the day when you can't see it? Is it still doing the same thing? Yeah, it is, but you just can't see it because it's not nighttime. Let's take a look at how it's done. The first thing we need to do is just set this thing up. So what we're looking for is the saw blades to be equal distance from whatever object we put in the center. In this case, it was just a double helix project I had left over. So what I did is set them equal distance apart. They're about 1.25 inches to 1.5 inches away from the double helix. And what it does when you move it too close, it starts to spark. When it stays far enough away, it hisses. And then if it's too far away, it won't do anything. Once you have the hiss, turn off the lights and you'll get this. Let's take a look at this other project. I built a coil around a all thread, and I was trying to get it to spark around in a circle all the way up. The voltage doesn't work that way. I went ahead and changed the coils just down to one coil so that you can see what it actually was doing. On this one, I just offset the coil a little bit, so it'll go high and low. Here's the power source. Here's the battery right here I use for my drill. This is a 1000-watt ZVS and an AC flyback. And this is my voltage multiplier circuit. The negative of the voltage multiplier circuit goes to the all thread. I put it underneath so that it doesn't come in contact with the positive. The positive goes over to the ring itself. Once you connect all those, it's time to light it up. If you're wondering how I built the voltage multiplier or the circuit itself that you just saw, I will add a video to the end of this one and you can go ahead and watch it, and I do the complete build on it. I wanted to show you two more things here with this coil that I thought were really cool. This one here, when you put the voltage into it, you see it sparking over. You can also see the lights coming out today. It's no longer nighttime. So you can see just barely some plasma in there. But the coil does move as you turn it on because it wants to roll towards the saw blade. You're probably wondering the other experiments with the coil, if you get something down the center, can you get it to light up? Well, yeah, I could. Unfortunately, the lighting outside just got a little lighter and it changed the effect, but it looks cool. As you could probably tell with a lot of high voltage projects I do, I use these saw blades because they are just awesome for putting out plasma. So I wired these all together, see if I could get them all to spark at once. I saw a guy on the internet put these between his legs and fired them all off. I'm going to give it a shot myself. So I got these two batteries here hooked up, and I'll just show you what it does. Yeah, that between your legs. All right, it's going to be fun.
I couldn't stop laughing the whole time I was
Remember when
doing
your
it.
mom told you not to do stupid things? Yeah, this is one of them.
I have no idea, but I was laughing the entire time, dude. I had no, you would think I'd be like worried, but I was just laughing, dude. I couldn't stop. Anyway, that's it. All right, Ben, what do you got? The old man right there.
All right.
All right.
So this is the exact
Hold on.
wire that we're going to be using. It's a 24 gauge magnetic enameled wire, and it's a brilliant red that's going to match very well with this vibrant orange that you printed, Nathan.
Nice.
And thus, I will name this prototype the Fireball.
Huh. Right on.
You heard it here, folks. First, this is the Fireball.
Yeah, I don't know if you want to try that. that may not work out for you. I got lucky, man, and didn't drop those things when I was laughing. That they were.
Oh yeah. No, you're
Yeah.
right. Let's go put this somewhere else where I don't accidentally knock it over again.
Oh, there you go. Yeah.
Set this to the side.
Tempted fate. Yeah, that's me. Oh, nothing's like doing some high voltage with old man builds. Oh, yeah, that's always fun, man. Lighting up plasma. Now, Sean's over there helping me with my testicle, and now I'm lighting it up that way. You just wait until what comes next, man. I almost set probably 3 of these together so they point at each other with that testicle. I will see if I can't create a singularity in the middle. So if you start seeing me with testicle winding videos, you better watch out because I'm going to be really lighting it up. We'll have to buy some more parts over here, get it all done. So that'd be pretty cool, man. Yeah, big fireball. Well, maybe. If there's wood in the middle, it's starting on fire. That's for sure. So I learned my lesson with wood next to it. That kind of get you going. Yeah.
So I set it down on a 6x12 cylinder sample. We get rid of them a lot of those at work. So I took the nice ones and I use them as displays. They're nice stands. They're concrete. Keeps things a little cooler. So I like them.
Right on, yeah.
And also, when I ship my coil, do you want me to ship you a small cylinder, a stand, or do you think you have something that you can?
You know what? Just show me how to wind it, Ben, and I'll wind it. That's all you gotta do.
Yeah,
I got like bunches of wire here. Like,
perfect.
Big rolls of wire here. Yeah, because
perfect.
I've been building Tesla coils and stuff. You know what I mean? So 5-pound spools is what I've been buying. And,
as long as you follow the instructions in my class, you'll be good. Yeah, just take your time with it. That's all. And even because sometimes it does take a long time when you're first starting out building these things, it's okay to set it, when you're in mid wind, set it down somewhere where it's not gonna be bothered, and you're not gonna disturb the wire, and continue it, take it periodically, take it one step at a time. Yeah,
no, I can't do that. My mind doesn't work that way. If I don't loop it right at that time, I'm gonna lose where I am. So
no, that's good. That I'm the same way, but just for some people, just so they understand, it's okay to, set it aside if you have to. Just make sure the wire isn't disturbed and you're not bending the wire unnecessarily. The only bends you want to try to put into it are on the spool to wind it, and the spool, and then to wind it on the frame. That's it.
I think I'm gonna mod your design, the one that you had me print. On the corners, I don't like that sharp corner that goes where the wire goes. I want to round that out. So
right. You got this. I got the spare here. Right here. I don't like the sharp corners either. Yeah, round that out. That would be nice. I mean, it's good that it's kind of hooks it in and traps it in. But if you have a zip tie, you don't need that there. You know what I mean? And that's what I do.
Yeah, that's what I think I'm going to do. I'm going to round those out because that looks like a mess when you go to put the wire in.
Yeah, it is. No, it is. And honestly, that's I did catch the bundle on mine a couple of times. You got to be careful. It'll scratch it or release it from that tight bind. And that could mess with the field geometry in unpredictable ways. So that's all stuff to consider. Also, if you look here at these openings, Nathan, if we can try to make these round ones just a V, just a tiny V shape, that's all we need to do to alter this to make it like a advanced 3.0 where we just set the wires down on top of
Or you wanted a rectangle.
I'm sorry, you said what?
You want that round hole to be a rectangle or a V?
A V. So it only space for one wire, but on top of each other. So you don't have a bundle. Yeah. So maybe I can pull up
They're trying to pull off another effect. Okay, I'm just trying to figure it out.
Yeah. But now that I'm thinking about it, I don't think it would be that hard to alter one of these designs to do that. Let me pull up the picture here.
Wait, watch this. You create the singularity. If you suddenly disappear, we know what happened to you. Yeah, you get sucked into the singularity. Huh.
Hey, if that happens, you have to take my coils and give them a safe home.
Hey Ben, what size you were using? 24 gauge or 23?
24, but you can use different gauges for different things. Like the Nunez's recommend, I think, 18 to 16 gauge wire at least for anything practical and energy generation. Like if you're using it as like a generator to power like a big load.
Okay.
Mm-hmm.
I got a bunch of 20 gauge left over from a generator I built, so I'll
So
use
this
that.
is, yeah, this is, and this coil frame is a lot smaller, obviously, but look, it's got a lot more notches. I think,
That's a single wire size, the opening.
yes, that's what I mean by a small V-shape opening. So it can layer them on top of one another symmetrically and evenly, but it's not enough for a whole bundle.
Yeah,
And
but
I want to try to.
It doesn't
You
look
said what?
V, it looks rectangle.
Yeah. Well, yeah, maybe I got it wrong, but still, like the idea is just to give it enough room for one wire.
Okay, that's a beautiful coil though.
Yeah, I
looks
want to
really
try
nice.
I want to try to build one of these too, but I have to get the frame, and I haven't been able to find a frame like that. We have to custom make it.
I'll see if they got an STL out there. I'll have to run it super slow. Some of those things, you can run them real fast, and then some of these parts like this, you have to really fine tune them and run them slow.
Yeah.
So.
Yeah, and with VBM, it's all about the spacing, really. So, well, that's something for a future day. That's a more advanced project than what we're working on right now. This is more along the lines of what we'll be doing.
Oh, that's cool. I didn't see the clear acrylic right away. I just thought he had it out there in space. That looks cool.
But even this coil, see, it's not tightly bound, but it's still together enough to compile the field geometries of each individual wire on top of one another. They're close enough so that they have some kind of accumulative effect. You know what I mean? Whereas if you have them just without the bundle and they're just in the spacing here, willy-nilly, like you see a lot of coils, I don't know if that's enough to actually do what we're trying to do here.
So Ben, let me ask you: when they cross over each other, would it help or not help to have any kind of I don't know, divider in there, like a piece of plastic or something, to give it space in between the coil? Is that a bad thing or a good thing?
So actually, you don't. That's a good question, but you don't actually have to worry about spacing with the second one as long as you use the zip ties, and as long as you use the zip ties.
No, that's not what I meant. I meant, would it be beneficial or change the outcome if you gapped them in between the coils? So you would go from two overlapping wires, two bundles that are overlapping like this, and then you put a spacer in between. So then you would have space, you know what I mean? With plastic in between instead of.
I mean, the only difference I think it would make is it would make it a little longer to wind, but it might help retain the shape a little bit. And yes, maybe separating those two might have some.
I guess I'm wondering, will it give you a capacitor effect? Can you get a capacitance out of it by putting a dielectric in the middle of it? It's kind of what I'm looking for.
That's an interesting way of looking at it. No, I don't know. I'd say it's worth trying. Definitely. It just for that, I'd say it's worth trying. But if in terms of trying to maintain the shape and all that, it's probably an extra step that you don't need to take. But
right. Well, I know that.
Yeah, but yeah, no, that's really cool idea. I didn't think about that way.
Create any kind of frame you want. Send your description, and I'll email it to you. Send me the STL right on.
Nice.
Yeah,
thank you.
I do a good job on Fusion 360 myself, man. Not too shabby at it. You have to be once you start playing with this stuff.
So this is similar to the Advanced 3.0, but it's got fewer notches. It's the same kind of. But yeah, so it's a lower fractal of the geometry, but it's still maintaining that spacing. So I'm not sure what kind of effect this has, what it's good for. I can imagine it's probably good for maybe magnetic field generation. I'm not sure.
You know, every geometry has its own story. So you just got to remember that.
I think until you test it, you really don't know, right?
Yeah, that's what I mean.
And get your hands dirty. Yeah, they got some interesting designs here. This is the small one that see how small it is? That
I couldn't do that. That I'd pay somebody to do. No, thank you.
No, I'm gonna do it, but
No.
it's gonna take some. Yeah, it's gonna take some time to do this one. This one's gonna be very, very hard to do. It'll probably be a long process, but we're gonna eventually try because I want to try to build all these different designs. They're so cool, and like we said, they have different effects. They're used for different things.
That's just a showpiece, man, right there. You put that on your wall.
Oh, I know it's so nice. You put it on a yeah.
I like that one.
And then this is another one. These ones, I believe, are good for spinning a magnetic rotary.
Oh, that'd be
how
cool.
It doesn't have the.
Yeah,
Yeah,
so look into that coil frame on that one. That one looks cool.
Yeah, I think I don't know. This might be one of the donuts with the grooves in it. I'm not sure. But it doesn't have the. And notice it doesn't have the interference pattern. And if we look at this video here. These ones are the same. They don't have the interference pattern, and they're being tested to drive these large spinning rotaries. So, and then this one has the interference pattern too, but it seems like maybe these would be better for generating the effect of rotating that motor. I'm not sure. But that's kind of what I inferred from it. But yeah, they had a facility where they were just testing these, and testing how long they would run and how efficient they would run and how big of a load they would put on them and all sorts of stuff.
I never knew that.
Mm-hmm. Yeah, they actually, before they went silent, they had obtained a lease in New York for a property where they were intended to expand all these experiments that they actually would have like a big place, like a workshop to do all this stuff.
Yeah, Sean's over there building more Tesla coils, man.
So this is cool right here. Look at this. It says, tonight we are spinning a 6-pole magnet rotor using a PoE vortex coil advanced 3.0, driven using 1.95 watts total. Next housing will have to be really more rigid. I think he meant rigid. But as you'll see in a second, it does need a better housing because this thing is insane. Watch this. See it vibrating? Tip. So it goes really, really fast on a relatively low amount of power compared to other systems that we've seen. This is another example of it. Like when you do this stuff, I would highly recommend wearing PPE, safety glasses, and even a hard hat if you have one.
I guess I will have to invest. I do not.
You can get a hard hat on.
I do not currently own those items.
That's okay. I mean, you can get them on Amazon, but yeah, it's just to be safe because, I mean, like I said, if the geometry is off or it could be unpredictable, maybe, or if the frequency is not in the range that it's supposed to be, who knows? It might fly up. I don't know.
Yeah. By the way,
just be careful.
I just where was it? Right here.
Mhm.
I just subscribed to Joel's channel because I wanted to see what that peg cell was all about. So, yeah, that was pretty cool.
Oh, that reminds me. While I have a stream going today, also I want to go over this device. I don't know if it's the PEG device, but it's this basically a system of PVC piping, and based on this system of PVC piping, it creates like a swirling vortex that creates supposedly creates like a buildup of pressure, and it can just like you get it going and it just sucks up water and keeps on sucking it up without any input. And the design looks very simple. And Bob Greenier was going over on a live stream, and it's something that I thought, like, hey, that wouldn't be that difficult to try to whip up and test and see if it actually works.
Is it a coil and it's pumping wire?
No, it's just PVC piping. Here, I'll play the video in a minute.
Okay,
yeah,
well, hold on.
When I find the video.
You do know you can create a vacuum in piping or a hose, and it'll suck everything out, right?
Well, the idea is that you get it going and it just doesn't stop. Like it continuously pumps out.
I understand. Yeah. I drained my buddy's pool with that. I just took a hose. I created a pressure in the hose, and then the water came out and it kept flowing the whole time. It never stopped. Just so you know. Yeah, it's an old school trick, man. The
process did seem possible. So, I mean, it did seem plausible. So I'd still like you to look at it to see what you have to say about it.
Yeah, dude, I'd love to look at it. I got a question, though. I got to ask Sean. Sean, can I show Charlie C's Tesla coil? I just thought it was interesting. I got to see if Sean's okay with that. So
what do you mean, Charlie C's Tesla coil? What was his Tesla coil?
Sean helped him with the Tesla coil, and he put some water to it. And it's not so much the Tesla coil that's sparking off that I thought was the coolest part. It's just, I don't use water in my computer at all, but Charlie used it to cool down his number 1 coil. So when Sean says it's okay, I'll do it. If not, I won't. So
yeah, I never thought about that, water cooling a Tesla coil.
Yeah, that's what I'm saying. It was just out of the blue. And with Sean, you never know what's going to happen when he's over there helping somebody. I mean, for God's sakes, man, whoever thought of a round Tesla coil? But
yeah. I know, like it's insane. It's really cool.
You used to see the other stuff he was working on, man. He's got so many windings in there with he used the square or rectangular. I can't remember which one it was, but it was the winding, the wire. It was actually like a square shape. It's totally different. So,
Bob Greenier's actually live right now. That's cool.
Right on. Well, bring up your video, man. We'll take a look while we're waiting for an answer.
Yeah, I got it up right here. I just need to look for the correct part.
Siphoning, yeah. That's just like you do to your gas tank. If you ever been poor and you got 2 cars of gas, yeah, you know what, 2 cars, one without, yeah, you know what that's all about.
Okay, I got it. Ad. Dang, I got hit with an ad. Stand by. Eliminating ad.
Yeah, you really need to get upgrade your stuff here, Ben, when you get monetized and get to YouTube without the ads.
Yeah, premium would be nice for live stream. Now that I'm thinking about it, you're right. I should probably do that.
Just anyways, when you get your money flowing in, you know what I mean?
Yeah, no, that's a good idea because I didn't even think about that, honestly. Here we go.
Through various variations. In this one, which is quite nice, this one here, they have a large tank here going into a well through a small bore tube here, okay, and a fat outlet. And they actually put a membrane on the top, which is see-through, a polymer membrane, and you can see it very, very substantially suck down, okay? So it's creating the same vacuum effect, but this is quite simple by comparison. And this is another very simple one, but like, I would encourage you to go and have a look at this. This for me is one of my favorite ones because I think this is the one we might attempt to replicate. It's really rather simple, and this guy has done a wide variety of these same things. This is different in that he forces the vacuum in this tube to create the initial effect, and it's not so plausible. But like I say, there's a wide variety of these things. You can clearly see the pipe here, and one might argue there's some sort of pump in here and so forth, but it's not hard to build these things. I know all the skills to do it, having just done it the last 2 weeks. So I think we might attempt this with Jordan just for shits and giggles. Okay, so I'm going to show.
So what do you think?
Yeah, no, you can do it by siphoning. Yeah, that's what he's doing.
Yeah.
That's all you got to do. You could suck on a garden hose in a pool, and it'll siphon it right out. You know what I mean? Just when it starts, the water starts coming in your mouth, you put it to the side, and it just starts coming out and doesn't stop.
Yeah, you just got to give it a little kickstart or whatever.
Yeah.
Show this video here because you get to see him build it. Okay. And, there's different links here, but I'm just going to.
What I like is they're using a lot more water, so it looks better.
Yeah.
You know what I mean?
Into a one standard size of pipe, and then it's got an expanded area here and a drop down. And these parts of the pipe are really just for support, and you'll see the thing being constructed. Yeah. Structures might be going on is that PVC can get charged. Okay. And there will be friction with the water. Water going up that narrow tube will create a toroidal vortex. In fact, it will be like a Kármán vortex street, but in toroids that are traveling up that tube. Because it's a polar molecule, it's naturally charge separated, and you've got the end molecules of PVC are such that they will likely encourage the easy water or inverse easy water. It doesn't matter actually, but charge separation within the polar charges of the water, that produces your toroidal vortex in the long thin column. And what that will do, in my view, is for a proportion of that water, it may cause it to produce water gas. Okay? May cause it to produce water gas. And the water gas then tries to push back against the check valve and closes it. And the only way it can expand then is to push water uphill. Because water gas, as we know, is 1,617 times larger than water. So you only need to convert a minute amount of this water.
Yeah, so he's basically saying you're compressing it in such a way that creates like a vortex, and that creates like a vacuum.
And it continuously works.
And it makes sense. And supposedly there's a lot of different devices like this, and it makes sense. Like, like from your perspective, you're like, yeah, we rig these things up all the time.
You've never siphoned gas?
No, I haven't.
Oh,
but
well, let me tell you the old redneck way to do it. You take your hose, take your little clear hose, okay? You shove it in the gas can, right? Mm-hmm. You suck on it until the stuff comes right up to your mouth, right? Then you put your thumb over it and just turn it down, and then let go, and it'll just start pouring it out, and it'll continue to siphon until it's gone because you created the vortex.
Wow, that's so cool.
It's the same kind of effect. It's a vortex. It's Schauberger, Victor Schauberger. I can't say his name for whatever reason today.
It's okay.
Schauberger. There you go. I don't even know if that's right.
But yeah, basically,
and even the forward head of the torus will cause.
He just has to give it a little start, like you said. Suck it a little bit.
Water gas to be synthesized, and you really only need a very small amount of water gas to be synthesized.
He's getting that
push
water
the water up against the check valve at the bottom, and that will cause water to come over. The water to come over will then pull a bit more water up, and the point is like, I almost don't care whether this is fake because it's so simple to try and replicate if what you're seeing is, what it is.
Mm-hmm.
Should have wrote it like a sawhorse or something. That'd be cool.
Mm-hmm. And we don't see we don't see devices like this really being sold, right? Because they want to sell you those expensive pumps with the motors on them and stuff.
Yeah, no, look, let's be honest with you. We could take a water wheel and create this suction, and just put the hose right over top the water wheel, and it'll continue to turn it, and you get free energy all day long out of it.
Yeah.
It's not a
awesome.
whole lot, but it's better it's better than a fan.
Right.
Why even put these big fans in the desert like they here have in California? Why? When I could just do this. So much simpler.
Oh, Raycar posted a video, water cooled spark gap. I might pull that up. Give me one
water cooled.
second.
I've seen that. That's pretty cool.
Yeah, let me pull it up real quick. Say I'm gonna vet it real quick to make sure it's not like pornography or nothing. You know,
No.
Sometimes people send us that, but it looks like a YouTube link, so we should be good.
Good for you. I click on things and get in trouble.
No, I do too, and I have to remember and remind myself, like, look, not everybody's an honest actor out there.
All right, Raycar, what do you got? Let's hope it's not pouring.
Yeah, this is no judgment on you or anything. This is just saying in general.
I'm just messing with him.
Yeah.
Oh, all right, man. What do we got? You got it yet, Ben?
I'm just typing it in. I don't know how to copy it. Do you know how to copy comments in StreamYard?
Copy them? I don't know.
Yeah, I haven't figured it out, and it won't let you copy it.
You can't just click on it?
No, it's hide or show. It doesn't let you highlight the text. So, not that I know.
Go back over to your normal stream and pull it up.
Oh, yeah, that's a good idea. Okay, let's do that.
Yeah, and just click on it. Yeah, they let you put them in the private chat.
I gotta figure out which one it's on. Is it on Bernie's or is it on mine? Raycar's and Bernie's. Okay, yeah, I got it right here.
Okay, got it. All right, let's see what we got. Do your vetting process.
Yeah, we're good.
Yeah, warning high voltage. All right, right up my alley. Here we go.
Yeah. Oh, let me mute the volume real quick.
Yeah, mute the volume. Oh, yeah, I seen this guy. He's like perfected some spark gap in water. It's really awesome.
What? I mean, water is a conductor, so it's just like you would have to separate the charges in order to do that, right?
Well, let's just see how he does it, and we'll take a look.
Yeah. He's like, come on, check this out. That's so cool. Look at that cube. I love it. That is neat. That's like applying the Tesla coil spark gap to art.
Wow. Yeah.
Yeah, look at that cube. I love the dude. I would pay for something like that. That is so cool.
Yeah, he's definitely got something going on there, man. I like it.
And that's water in that little dish? Yeah. 30-degree angle. Hold on. I want to go back. I want to take a look at that. That was quick. All right, so we got PFR positive flow receiver on the top. We got the GFE ground flow emitter coming in from the side and up through the center at a 30-degree angle, and then the water filling the bowl.
Yeah, I agree with Raycar there. He does have some awesome videos. I like this guy.
Yeah, let's check this out. Actually, I gotta go to the bathroom, so I'll be right back. But I'll
he said throw on some closed captions while the volume's off.
Yes, that's a good idea. Thank you. I forgot about that. All right.
Oh, look at that. You just 3D printed those, huh? That's pretty cool. That doesn't look hard to build.
No, it looks kind of simple. Huh.
Oh, it's way awesome. All right. I can do that. Gonna have to give this a try. I got plenty of high voltage around here. Okay, simple wire. Pick that up at your hardware store. Right there, just copper wire. Cool. Oh, look at that. He's got different ends. That's pretty awesome. Just switch him in and out. Let's see. He's got the same setup in all of them. That one's got 3 wires coming off it. Never one. Okay. One gets you fire. Ooh, I might just try one just to see it. Yeah, experiment with different shapes. Yeah. What is that? Tesla coil? It looks like it's Tesla coil.
Wow, that's cool.
Asymmetric spark gap. Huh. All right, what do we got? We got a bunch of them in liquid. What does he got going on there? Because man, that looks just clean.
Yeah, and there's something in the water over there. It's like blue.
Yeah.
Electrolyte, maybe?
Charge capacitance, huh? Safety electrode. I gotta try safety. Oh, so he's got special water in there too. Okay, hold on. This reminds me of something like EDM or something where they use high voltage and some water to cut through materials.
Is that it? That's cool.
Oh, that's cool. Oh, yeah.
That's neat.
He's talking about splitting water in two, huh? That's cool. I have to go back and rewatch that.
Is he talking about separating the charges? Is that what he means by splitting it in two?
I'm sure it'll tell us in a minute, huh?
Interesting.
Right on. Yeah, that's a cool video, man. I like that.
So I think I'm gonna check on the frame here. We might be ready to start that wind pattern.
Yeah, get that wire going.
All right. It feels solid.
Nice.
Yeah, we good. So while I do this, let's. I had another video that I wanted to pull up and check out.
The water molecules are reduce weak nuclear forces, I guess. That's cool. I like that.
Good evening. Welcome to my laboratory. What I've got here is a Tesla bifilar coil, flat pancake coil. It has an inductance. This is the one I just wound. It has an inductance of about 640 microhenries. And this is a little magnetic compass. And right now it is pointing correctly to north. And what I'm going to do is set it down on the Tesla bifilar coil right there. And I have the Tesla bifilar coil hooked up through a 54.3 ohm carbon resistor to the output of the Interstate F43 function generator. And I've got the function generator set on a very slow pulsation. This is not nearly as slow as it will go. I'm still in the normal range of the frequency multiplier, not the 1/100th frequency. But we're down near the bottom of the dial, and I have it set to produce a positive and negative going square wave output. Right now I've got the output turned way, way down. And what I'm going to do is just turn the output up while you watch here. Okay, so here comes the output turning up. And now I'm going to play with the frequency just a little bit. I'm just very carefully adjusting the frequency. When I get it set just right, get that. There we go. Now, does this mean that there's a rotating magnetic field in there? No, it doesn't. This is a type of mechanical resonance where we're driving the positive and negative going field, which is radially looping through the coil like this, at the correct frequency to mechanically resonate, if you will, the magnetic compass. And so it goes around in a circle. And if I can catch that just at the right place, I can actually make it accelerate. That. No, I'm just very gradually increasing the frequency of the function generator. Okay, oops, it dropped off, but you can still see the compass dipping there. Let's see if I can get back down to a value that will start it oscillating again.
So this actually, now that I'm watching it, is explaining magnetic synchronicity a lot better. It's not actually spinning. The magnetic field isn't actually spinning, but it's that's causing the neodymium sphere to spin. But it's actually resonating with it. So it's causing it to resonate with the pulse that you're providing it, and that's providing the spin. At least according to this video, which actually makes a lot of sense. So with that, I'm going to show you real quick before I start winding. And then Nathan, if you have anything you want to show us while I wind. But I started, here, let me, how do I pull this up? Okay. So I started, as you can see in the middle here, actually, I started on the wrong one. My bad. So we're going to start in the middle. Don't do what I did. We're going to start in the middle one here, right where the ring is. So if you can see that right here, we're just going to loop it around a couple of times and give yourself enough lead for you to actually use. So don't leave yourself with like an inch to use and to connect to something, you know. And what we're going to be doing is we're going to be taking this wire and stretching it all the way across to the one right next to it, and then going up one. And then every time we're going to do that same process. Stretch it over and then up one, right? Next ring, stretch it over and then up one. So you're creating that. So you're creating that curve, that incline. And while you're doing that, keep in mind you want to, try to smooth out all the bends. I know the bundle will be easier to work with because it'll be bundled together and it'll have more structure. But if it's like you see like a little bend, catch it fast. A stitch in time saves 9. So by the time, you don't want to find yourself at the end of the wind and find, oh, you got a small bend here and you want to fix it. It's not really going to fix because you got all that tension already on it. You know what I mean? So I'm just going to continue this process and Nathan, if you have anything you want to show us, pull that. Here we go.
Oh, there I am. Okay. Yeah, I got something to show you. I'll probably get in trouble for this, but I'm gonna do it. It's not anything bad. It's something super cool, but I don't think I have permission. But I'm gonna share it. So this right here is Charlie C's Tesla coil. Look at the water in there. Go into his #1 coil. I just think it's so awesome. It cools it slightly, but it's more of the look. It just kind of it adds something to a Tesla coil that you don't see every day, but it's still functional. So I'll hit play on that. That's so cool. I love the water going in. Huh. All right. So anyway, that was pretty cool. I just wanted you guys to see that. It's just a water pump from a computer, like, and he put it right into his coil. I just thought that was so interesting. So let's remove that. I'll go ahead and show you guys. I built my Tesla coil and got it going too a while back with Sean's help, and I'll show you that. Let me just share the screen. And here we go. So it's pretty simple. This is just a ZVS, cheap $30 GVS. It's got 2 different capacitors. We took out all the other ones that were in there. And it's really cool. It runs on AC right there. And we hooked it up special. You have to watch the video to figure it out, but it's really easy to do. Got the Variac. All right, let's get to the good part. So you can see I drew exactly where everything is straight across from it. And we actually get close to a 12-inch spark out of this thing. It's really amazing. So, come on now. Let's get it to the point where it lights up. There we go. All right. Oh, let me turn the volume on that. We have got 8 inches. You can hook the 9. So you might even be hitting what? 10? Yeah, I hit 12 there. Let's just so you guys know. I got it up to 12 inches on that Tesla coil, man. That thing was awesome. By the way, thank you, Sean. Big shout out to Sean right here. One of the most amazing people I ever met, and amazing at building Tesla coils. So thank you. He helped me out with that a lot. So that was pretty cool. Yes, I'll share another video with you. I want to share this. So we're just going to look at this. I had somebody validate this while Ben's working over there. What we're doing is we're changing frequency and amps and everything else.
Going on here. So cruise over here, right? So you notice what's happening here, right? You see how the frequency is changing, right? We have response there. Now let's look over here, right? So we initially dialed it up to 12 volts, but you can see we're just under 4 amps of draw, right? So when we actually change the pulse width, check this out. See that? See how the amps start dropping and the voltage rises, right? It's an inversion. All right, we'll go the other way. Notice the amps are rising, voltage is dropping, right? There's your duty cycle action. I haven't adjusted the voltage at all, okay? Now when we look at the frequency, what happens this time, right? As I go up in frequency, the amperage drawn goes down, right? And there it is, you hear that? That's what we're talking about right there. He's totally right. There's a 5-to-1, okay? As we know, everything is connected. You know, you can't just change one thing and expect to get something, you know, isolated. Everything changes and moves with it. All right, so we're also looking at the actual resonant frequency of the flyback system itself, right? So I'm changing the pulse width. You notice we've dropped in voltage, right? There's a raise in amperage, pulse width down, right? Raise in voltage, drop in amperage. See that? Now we're increasing the frequency. Now we're decreasing the frequency. Now you hear that, right? So we're coming out of the ultrasonic range. Right, and this has a lot to do with the resonant frequency of our flyback, right? So everyone's slightly different. You got to kind of find your zone. So look where we're at right now. 8 grand. Right, let's take it all the way. Right. So you see that now we're way high on the amperage, right? So we'll change the pulse width. Yep, wrong way, right? See that? Lowering of amperage, raising of voltage. Right? You can hear it kind of slowing down. So yeah, highly recommend checking out Old Man Build's video on this particular subject. There is a lot going on, right? All right. Thanks, you guys, for watching. Hope that kind of makes some sense, right?
So as you can see, everything in there, it just changes. So when somebody tells me the wattage on their project, it's kind of hard to evaluate all the time because your volts and your amps change no matter what your wattage is, because the wattage is simple multiplication. So yeah, you kind of have to watch it and see what it's doing. And it's just cool to see somebody out there that took my understanding, because all I did was a video like this, and I was just talking to the camera and telling them what goes on based on, you know, the projects that I have going on in my garage. And then he took that and he did the test himself and found it out. Now, I've done that test a million times. I can tell you it works all day long. But to see somebody else do that and validate your work was totally awesome. So big thumbs up, man. Thank you for that.
It's really cool to see. That is.
So how you doing on your coil there, Ben?
Good. I had to start the wind over again because the wire got tangled. I guess it was tangled in the spool, so I just cut it and start over.
Oh, gotcha. It'll be a while.
Yeah, it could be a few minutes, guys.
Yeah, right on. We'll just find another video, man. See what else we got on this thing. Oh man, let's check this one out. I don't know if you guys are into this kind of stuff, but I definitely am. Let's see. We'll share this. On the French think tank, we had the opportunity to have Merkaba in. He built a machine that he calls the Merkaba machine. What it does is it's shaped like the actual Merkaba, but on the inside it's using sound in order to spin a neodymium magnet that's circular, or a sphere. That sounds kind of funny, doesn't it? Sound? You don't see a speaker in sight. Well, I guess you could say he's using frequency to do it. I like to look at it as using sound to do it. Either one. What's going on is all of the wrappings that you see around it creates a magnetic field. And then he takes another coil, and you can see where the arrows are. Those right there are making the second coil. So in a way, it's like a speaker. Is it producing sound or frequency? Well, to give you a hint, he's using a stereo receiver in order to drive everything. When we had a chance to talk to the inventor, he said that he can change between the frequencies, and each frequency would make the neodymium ball do something a little different or spin in a different direction. You could not use every single one of them at the same time, but you can use each one of them at one time. So if you had a song playing, it would then go to each one of them and turn them on individually. Now that I brought you up to date on what the machine is doing, I just want to tell you I keep getting a nagging feeling. There's something more to this that we're just not seeing. I keep seeing it in my head, and it's about time that I get it out. This is what I keep seeing in my head. I keep seeing a round sphere of water. I continuously see the quartz crystal on the inside. I also see two rods going in there, and they have little flat ends so they can sit against the crystal. I know the configuration sounds strange, but jump down the rabbit hole with me and let's take a look. If we understand piezoelectricity, when you strike two pieces of quartz together, they create light. What they're doing is creating energy on the inside. Now, we generally use quartz crystal as a clock feature. Tap it once, it taps back. Put tuning forks on both sides and you can activate it. Put it in pressure, and then you can use it as well. It's great for tuning. However, when you want power out of it, you must activate the crystal in a way that is not like everything else. It needs to be smacked together, or it needs something smacking it. So how do we accomplish that? Well, you can't just go smacking two crystals together while it's in a bowl full of water. That doesn't work at all. Right now, the machine is set up to put out sound or frequency, and that's not going to do it either. So we have to change this just a little bit. Let's attach those coils to piezoelectric discs. We'll put the piezoelectric disc on the outside of the sphere of water. Then we can create a pulse wave to go into the water. So I know what you're thinking. What's a little pulse wave going to do to this? Well, if you connect, instead of a stereo receiver, you connect an ultrasound device, now we're getting a pretty heavy pulse. But please understand that piezoelectric discs are receivers and transmitters. So while each one's going off individually, the other ones are receiving the same signal. It's going to create a giant echo chamber in there, or a resonance chamber, in order to resonate the actual quartz itself. That's where we're going to get our power. Let's just talk about the shape itself of the quartz. It's actually set up as a Merkaba as well. Now, this is for a certain reason. As you see on your screen, all these balls coming into the center of a Merkaba. What is it that we're looking at doing? Well, this is actually from the creator of the machine, and what he's saying is the energy itself goes into the center just like that. And it doesn't like to stay there perfectly. It keeps moving in continuous motion.
That's exactly what we want to produce in the center of our quartz. In order to activate it, we must always keep it in a resonant state. So now that we have all this energy in the center, how does the energy flow actually work? If we were going to talk about the conventional way to use quartz crystal, we would think energy in, energy out. But that's not what we're doing here. We're taking piezoelectric disc and we're creating a pulse wave in order to activate the crystal inside. So all we need to do is pull the energy out. Because the energy needs to be activated in something, you cannot pull it out by putting pressure on the side. You can get a small amount of energy, you cannot get a big amount of energy. Therefore, the fluid itself has to act as a go-between. It has to be able to go with the water getting energized, and then you pull the energy from the water. Therefore, in the end of each rod, you would need a sponge-like material in order to keep it always wet and always flowing. Because we're in the rabbit hole, let's go ahead and jump in a little deeper. Ask yourself, over time, did we tell ourselves it was there? Do we have these shapes all around us and we just don't understand what they're for? Let's take a look at many shapes around here that are in the macabre shape, and let's see what people think about them. As I see all these shapes and structures, I'm starting to realize one thing. Maybe it's all supposed to be this way. Crystalline shape in the center, macabre on the outside. Maybe there's something to this. It seems that everybody who looks at these has some form of this vision in their head. Otherwise, they have one other. It seems to be that they are telling us that there's something that has to go into the crystal. We see these shapes doing it. There's also these shapes where they go around it, saying that there's some kind of uniformity to everything. When I said it was like a resonance chamber, maybe they thought the same thing. Maybe this image shows that it was a resonance chamber. Since we are completely lost in the rabbit hole, let's continue one step further. These are the images I also see out there. A human figure inside the macabre. Why would that even make sense? Well, we have crystalline in our body. We actually can make it when we have gout, or it's in our brain as well. It's crazy. Maybe it's saying that we can communicate on some scale once we actually activate the crystal itself. That's just amazing. But there's one more step in the rabbit hole. We can go just a little deeper. This is what I keep seeing. However, someone else must have seen it that way too, because this is what they made. This is what they drew. This is what they put up in their program in order to make it. So you can see this picture. Is it really, truly the energy source for a ship? Is there something more to this? Well, we're just going to have to find out, aren't we? At some point, we're going to have to build something like this. Guys, we're already deep in the rabbit hole. You never know what's coming next. That's why it's the Fringe think tank. It's not the NASA think tank. It's not the everybody approves of it think tank. It's the Fringe think tank, where we go outside the box and look at everything everyone else won't. If you want to catch an episode of the Fringe think tank, it goes on every Monday night, 3 p.m. Pacific Standard Time. That was pretty cool. Ben, where you at?
So I am on the fourth go round on the first pattern, not the interference pattern. So here, I don't know if you can see.
Hold on, let me put you up solo here. Hold on.
So as you can see, I'm on the fourth one. And it's a little bit easier on the second and third round because you can kind of use the first one as a guide where to go.
How many times you got to go on that?
Let's see. It says Depends on how many you have. Let's see. 1, 2, 3. 3, 4, 5, 6, 7, 8, 9, 10, 11, about 12 or 13.
Huh. 13. So you can't wrap it once and then multiply it by how many you have?
Oh, that's what I'm gonna do. No. That's what I'm gonna do. But I'm gonna wrap it one time, and then the one time with the interference pattern. Yeah, I'm gonna wrap it fully, and then I'm gonna take it off and then measure the hole.
Gotcha.
And then multiply it by 24.
Okay, that sounds better. I was gonna say you'd be there all day.
No. That's the plan, and it's not gonna take that long. As long as I got it started here, it's gonna take maybe another 15, 20 minutes tops.
Yeah, that's pretty cool, man. All right, let me put you back on normal. You can go back to winding that thing. All right, let's see what else we got going on. I like that Makaba machine. By the way, on Monday, Makaba should be joining us. Okay, we also have Ian joining us. So those two in the room with the rest of us, man, it'd be totally awesome. So, yeah, it's going to be a pretty fun show on Monday. So I can't wait for that, man. I'm
excited, man. You got me all excited, Nathan. Is it Monday yet? Come on, guys.
Yeah,
if you haven't hit that subscribe button, hit that subscribe button and join us tomorrow, 6 p.m. Eastern Standard Time or 3 p.m. if you're on the West Coast. Yeah. It's going to be a great show. I can tell you that if we have those guests on.
Yeah, both those guys were fascinating last time. So, I can't wait. And the way they do things and the sound and everything, they both talk about harmonics and stuff like that. So, yeah, awesome. That'd be just awesome to hear the conversation between the two of them on that alone. So, I'm excited for that.
Yes. Ideas are coming together. People are coming together. If we could have a in-person potluck at this point, we would. You know what I mean?
Well, like Gerald said, it'd have to be on the Canadian border up there where we all got together.
That's fine with me. Yeah, I'd be up for that too, for sure.
So let's take a look, and we'll go to this one. Normally, I would tell you exactly what's going on. Normally, I would tell you exactly what's going on in an experiment. However, this time, I'd like to hear from all of you. What do you think's going on here? As you can see, that's not paper. That's not foil. What it is a piece of packing material or styrofoam type material. So let's see what it does. Not quite lifting. It's clinging, and then it lifts. That's pretty cool. I bet a lot of people right now are thinking ion wind. Is it? Let's see the next one. Now we have some paper in there. It's got some sharp edges, guys. Look at it. Oh, it's just bouncing in between. Is this a little bit more of two fields and something going in between it for a little levitation effect? This is the power source behind the whole thing. Let's take a look. So the actual experiment's pretty small, and we can see on the very left side that we have a DC power supply. We can see on the right side we have a motor driver, and then we can see up on the top we have a DC flyback transformer. So we know that there's high voltage going on, and we know that the high voltage is actually adjustable. So here's all the parts for it. Now, let's go ahead and take a look at possibilities that this could be. This right here is possibility number one, levitation. We've all probably watched this on the plasma channel. You have an anode on the top, a cathode on the bottom. It's high voltage, and in between, you have a piece of tin foil. It works on changing the actual charges in an item in order to get it to levitate where it is. Here are the charges that you can see right here. Negative on the top, positive on the bottom. The negative goes up to the negative, and the positive is subtracted also to the bottom. Now, this experiment cannot work with sharp edges on the top. It has to be rounded. On the bottom, it doesn't matter so much. So, is this a possibility? This is possibility number 2. It's ion wind. This is an ion wind lifter. It has a high voltage wire on the top, aluminum on the bottom. Positive goes to the top, and negative goes to the aluminum on the bottom. Now, it also has to work with a sharp edge on the top, and then it has to be a rounded edge at the bottom where it starts, and then as it goes down, you can get any kind of crazy you want, and it'll still work. However, it still works between 2 high voltage fields. Like I said, the high voltage is a flyback transformer to get this one to work as well. The wind is created between the top wire and the bottom aluminum, and it forces the item to go up because the weight is reduced enough that the wind will actually propel it up. Is this a possibility of what's going on here? So let's throw a curveball at the ion wind people out there, because they always tell me everything's ion wind. So let's reverse the fields. Negative on top, positive on bottom. What happens? It'll actually pull down to the table below. Also in ion wind, if you do not separate the table itself from the ion lifter, in most cases it will not lift. Why? Because the polarization of the charges will suck it down to the table. So is it still ion lift? Let's see if we have another possibility. Let's go a little old school with this one. This is a static electricity experiment. It works by putting paper on the ground. Then you charge your body with static electricity, and the paper will actually lift to your hand. This experiment works because the negative is actually the ground itself, and the positive is the static electricity. It gets the object charged, and as it's charged, it'll lift towards the positive charge. Now, this isn't ion wind at all. This is charged particles. So is this a possibility? Is this something that that's going on here? Let's go ahead and take a look at the experiment one more time. This was the second one. This is the paper. As you see, it sits in between 2 fields. Now, there's no change in the electricity in this, guys, between what's going on right here in this experiment and what goes on in the next one. It's the same power source. As you can see, we got a foam type material here, or a different type of material anyway, more like a scrubber pad type of material here. Anyway, it has different properties as it lifts here. It is not the same type of lift, but the power source is the same. So, is it the same thing? Is it the same process going on here? Guys, this is a question for you, not for me. So you tell me in the comments, what do you think it is going on here? Is there more than one effect going on here? Is it basically just ion wind like everybody claims everything is? Or is there something more going on here? All right, let's go back to the regular layout. What do you guys think it is? Any guesses out there? What do you think, Ben? You got an idea?
I have absolutely no idea. I know it's not what we think it is, though. I know it's not ionic wind.
So what everybody tells me in the comments when I do something like that. So I'm always kind of curious what people seem to say. So, well, I guess nobody's going to answer it. So I'll just answer it for you. He's charging it. He's just creating a charged field. Mm-hmm. And in that charged field, it moves from one to the next. That's it. It just has a flow direction. That's about as simple as it gets. It's the same thing when I showed you the stuff from Plasma Channel. He's, Sean got it. Electric charge and repulsion. That's exactly what it is. it's easy to identify when you've done it. It's so hard if you've never seen it before, because you start guessing at everything that it could be instead of, hey, it's directly this. You didn't see any plasma breakout, so ion wins out of the picture. You see that it's between the two fields, but even if you turn the light off and that same experiment's going on, there is no discharge happening. That's a state where you get absolute charge. That's it. It's just moving between two charged fields. So anyway, just thought that was pretty cool. How you doing over there, Ben?
Doing pretty good. Almost finished with the first wind pattern, and then we're going to start with the interference pattern.
Man, that does take a while. How long you been at it now?
Well, I had to start over a couple of times because the wire got tangled, and I decided to switch to this small spool, which can fit through the toe of the donut. So I'm not going to mess with the wire and not because I've done it before. You have to be very careful, and when it's bundled, it's easier to do. But this single strand wire, no, it's just going to get tangled if you don't spool it up or have it, in a neat spool like that.
Should have got that rope.
Yeah, I wanted to do this and get it done though, and it's something that fits in with today's class, so it's all relevant. I think it's no big deal. I like doing it.
Yeah, by the way, Sean, you're probably right. Anti-gravity. So anytime you're in a static field, you have an opportunity for an anti-gravity effect if you can create a longitudinal wave in it. So yeah, you just have to know that. And once you do, the secret's out, man. You can start doing some of this stuff. So yeah, it was pretty cool. Man, England, 9 hours difference in the time. Man, that's a lot. That's Makaba's out that way. I think every time we connect, it's like 8 hour difference. So yeah, probably a different part, but yeah, got it. That's pretty cool. All right. So we'll have to find something else to watch, huh, Ben?
Yes.
All right. Let's see. What do we got going on now? Let's see. We're talking about static charge. Let's just get into it, I guess. Guys, have you seen the paper lifter experiment at all? You guys know what it is? I'll pull it up. I'm going to use absolute charge on this thing. It's really cool. If I can find it. So, is that you in the background, Ben?
Oh, yeah, my bad.
Huh, it's all right. I'm just listening. I hear some weird stuff going on. Oh, yeah. Okay. Once I get past all the high voltage on my channel. Okay. Paper lifter right here. Okay. So this is a pretty cool experiment. This is when you take out everything and just show the charge on it. Guys, this is really cool. It's a little paper lifter. It's just made out of printer paper. And the top is positively charged and the bottom is negatively charged. And I just want to show you this. As you plug it in, it lifts and then it lets go when you unplug it, and it'll stay right there. Now, usually this is done with a Wimhurst machine, static electricity. This time we're doing it with high voltage. To show you, just plug it in, lifts, and there's a lot of wind that comes off of it. And maybe I'll show it on my fog machine later. But there's a lot of wind that comes off of this thing once it's plugged in. Now, I did change the voltage source to get it a bit higher. I ran 2 of these in series, okay, with one driver, okay. And again, this is just a, 19 volt and 2.37 amps is the power source here. I don't know if you see that any good. Anyway, this is just the power source. But they run positive to negative, and then positive obviously goes up to your positive top plate, and then negative goes to your bottom plate here. Okay, it does make a difference on size. The top has to be bigger than the bottom. I'll link this to another video where the guy does it on the static electricity machine. But I wanted to show you with voltage that this can be done as well. It's part of lift. So hopefully, that's a lot of voltage right there. That's probably about 2 inches in voltage is what it comes out of this thing. It's pretty gnarly. I think I can maybe up it with some capacitors that I built. So let's see. I just wanted to show you guys. There's no ion wind there, by the way. When I ran my fog machine on it, there wasn't any. It was all stuck inside that little paper UFO. There was no ion wind. Okay, it was crazy. I put the fog machine on it, and you can see it. We didn't move. So pretty awesome experiment. Teaches you about charge and the difference between creating ion wind and charge and what they do and how far apart you got to have things. The actual voltage going in. Like I said, the first guy used a Wimhurst machine. You can also use a, what do they call it? Big static electricity machine. One of those things, you can use that. Or you can use high voltage DC if you know what you're doing. It'll all do the same thing. It's all about charging up that UFO and getting it to move. So that was it on that one. Oh, you almost done there, Ben?
Almost.
All right, I'll find something else. Let's see if I have some more experiments on this. Let's remove that one. I'll share another one. Let's see which one it was. Oh, okay. Paper lifter experiment. That's the one it is. Right there. No, that's not it. Oh, wow. There we go. That's the one I want. So this one here is upside down, and it shows the force. So I just wanted to show this. I'm going to turn the power now. My question was on this is, if you flip it upside down, will it still try to lift? And, well, the answer is no. And what's going on is, oh, there you go, Van de Graaff. It's heavily forcing itself down now to this bottom plate. It's going the opposite direction. So just like it was on the lift, it's attracted to the bigger plate. So no, not by turning it upside down will it do that. As a matter of fact, it just forces this bottom plate the more you do this straight down. So there's a heavy lift factor there, or weight factor there, however you want to say it. It's definitely pushing against the bigger plate from the smaller one. So we'll have to figure out a little bit more on why. And then maybe we'll throw in one of these aluminum foil change of plates. We'll see what. Anyway, that was pretty cool. So,
yeah, that was neat.
Turn that off. All right. So clear these out. Sean wanted to see the UFO bubble. So let's see. Let's put that on. Take me just a second. Okay, this is, by the way, I'm going to show you guys this. This is the theory on how to create the field bubble in a UFO.
Somebody what a UFO field is. Generally, this is what comes to mind. So when I tell them it actually looks more like this, they get completely confused. They don't understand why there's a field inside the UFO and also why this field continues to build. The simple answer is the outside and the inside are built with two totally different forms of energy. To better understand this, let's just go back to the basics. This is a simple toroidal structure, and if I ask you to build a field around it, this is the most common answer that you would give. A toroid builds magnetic field lines that go around it in one direction. The next step would look like this. You add wire to the toroid. Then it builds a field based on the wire and where it's placed. The problem is, a toroid or a toroid with wire around it does not build a field that looks anything like this. So let's just start over. Is a toroid really what you want at the center of your UFO? And the answer simply is no. So if it's no, what do we need to put there instead? We need to build a flow pattern into the coil. And there's no better way to build a flow pattern than to use sacred geometry. So we start with simple shapes that we know that we can put into a toroidal fashion. Then we start to make them more complex. Each time that we make a shape, we put it into a wire form. Then we test it and we check the flow pattern. We see which ones match and which ones don't. For every new pattern we try, there's always a different outcome. How you connect them and how each one flows matters. We will start to see effects in everything that we do. Sometimes the energy flow can rotate a neodymium sphere magnet in circles. At this stage, we start to push it. We start to imagine this as a 3D shape. Then we start winding coils to build it into a 3D shape. We're looking for a flow. We're looking for energy to move from one point to the other. And what happens when one thing crosses another? And can we still rotate the neodymium magnet in it? The answer is yes. The question then becomes, can we add multiple magnetic fields inside of this coil in order to get something different to happen? This journey is not going to be an easy one. It's not going to come overnight. It's going to take a lot of time and a lot of patience and a lot of practice to get it right. Every single coil you build is different. Every single one has a different outcome. Every one of them creates a different field geometry. It's going to be important to log every single test as you do them so that you can refer back to the notes of the video footage that you took of each single test. This is not an easy task. It will take a lot of time. Please be patient, but the understanding at the end will be completely worth it. But once we have our field coil and we start to understand what it does, what else do we need to put into this device to get us our field flow? Because just this coil as it sits is not going to do it without adding certain effects to it. As we look back at our UFO structure and how the fields are built, we also have to realize we need different types of energy. We're going to need a magnetic field, and we're also going to need a static field. Let's start with the magnetic field. We can use a Tesla coil in order to create a magnetic field on the outside. However, the standard Tesla coil has a weak field that comes out of it. We need to strengthen that or thicken the field. The only way to do that is to rotate the Tesla coil. Now, at this point, I know what you're thinking. We could just put a wire on top of our Tesla coil, spin it, ion wind will spin it around, and we'll get a rotating Tesla coil. However, that's not a rotating Tesla coil at all. That's usage of the Tesla coil that expels energy out, but doesn't give us what we want. we physically need to turn the Tesla coil. In a standard Tesla coil, just sitting on your table, will produce energy that looks like this. You get the energy flow pattern that goes around in a circle. However, in the center, you will also get the Tesla coil ring. It is a very distinct looking sine wave. You will see it build up and disperse energy. That's where the energy comes from. It accumulates in the coil and then it bursts out the top. As you can see in this, we see the ring right in the center. The Tesla coil doesn't put out necessarily lines of energy. It puts out a field bubble. However, in order to thicken that bubble and put it around our UFO, we have to rotate it. You have to continuously start new field lines every time that it goes around. Therefore, it'll make the whole thing thicker. That's the only way to get a proper bubble around our UFO. Besides the field bubble, a Tesla coil provides a longitudinal wave. This is going to give us direction on our UFO. It's going to say whether we go up or we go down. As many of you have already figured out, a regular Tesla coil configuration is not going to do that. We are going to have to build a bipolar Tesla coil. We also need to change the orientation that a bipolar Tesla coil is normally in. Again, we're looking for the field energy to go north and south. That means it has to stand straight up with the coil in the center. Now that we have a better understanding of how the outside magnetic field is built, now we need to look back at the static inside field that needs to be built as well. This is an ion thruster. As you can see the purple in it, it's making ion wind. The problem here is that it's using the energy. The energy is being transferred into light. It's also being transferred into ions. Therefore, the energy is being used in this process. We need to lower the amperage on this energy in order for it to become static energy. If you do not do this and you do not understand the relationship between frequency and heat and frequency and amperage and voltage and frequency, this is going to be a very hard task to pull off. If you do understand the relationship, then changing this plasma into a static electricity should be the easiest thing in the world to do. Now, it's imperative that it comes out as static electricity. If it comes out as ion wind, you are using the very energy you need to be produced in the bubble and wasting it. It will nullify the field you're trying to create. As you take a look at this picture, you're starting to understand how the fields are being built and why. On the outside, we see our Tesla coil field. It's magnetic. It's going to hold in the static field. The static field in this is shown in purple. We can now see the outside field holding in the inside field. We can also see the flow of the Tesla coil as it wraps around and goes back into the center. What you also notice is the static field does the exact same thing. What does that create in the center? It creates an artificial 0 point, a point in which the energy is now.
Hey, Ben, you get done?
Yes, I'm done, and I'm just going to start the interference pattern so you guys can understand how it works, but I'm not going to finish it. I'm going to use this and then times it by 24 and then times that by 2, basically.
Okay.
So we have...
Hang on.
Oh.
Let me just... Oh, there we go. Go ahead.
As you can see, we have a nice wind pattern, and it ended up exactly where we started. I'm going to actually cut this so I can hold it up. Give me 1 second.
By the way, Taryn, yes, we did. I received it, and I've been looking at it.
All right. So, as you can see, we ended up right where we started, right? Now, what do we do with the interference pattern? This is our start point. We're coming back. What we're going to do is bend it underneath and go downward. Let me start it here. So this will give us our clockwise wind. We started counterclockwise, now we're going clockwise. It's really hard to frame this.
Nice.
So you can see we went underneath and we just bent it. And we started going the opposite way. And then we're just going to do that. But I'm not going to finish it. I'm just going to unwind this and count it. Or I'm going to stretch it out and measure it. Actually, I have a wheel measure. I should probably do that in the backyard. I'll do that. All right. Yeah, that'll take a minute, though.
Right on, man. That looks pretty cool. So, looks like he's out to do something. Ben, you taking that outside to unwind it now?
Yeah, so I'm going to unwind it, and I'm going to take it outside and stretch it out, and then just use a wheel measure that I have in the truck and just, run it out and see how long it is.
You going to do that later, or you going to do it now?
I'll do it now, but I don't think I'll do it on camera. I'll probably do it off camera. I don't know if I have the capability. Maybe I can put my camera out there. Well, we'll see if the camera works. If it works out there, it works. But if it doesn't, it doesn't.
I think, Ben, it's going to take a while, so you should probably might just add that to your next live show before you start winding. You tell people how long it is. You know what I mean?
What time is it? Oh, it's already 7. Yeah, you might be right. It's already 7.
You've been on almost 5 hours.
I'm having so much fun. No, I really like building these coils. They're fun. Look, it's
Hold
not
on,
like,
let's show this off.
Yeah, it's hard to see because it's just one wire, but the pattern you see in the center, how it produces that vortex pattern in the center. It's very cool, and that's not even the interference pattern. That's just the one wind. So, again, this is not the final design, guys. This is just to measure out how much coil we actually need for this big boy here.
Yeah, great job, Ben.
Thank you. Thank you. It's not perfect, but actually, when we have it with the bundle, you see all these like little bends and imperfections. When we have it with the bundle, it'll be easier for that to straighten out. We can, as we're going, keep it straight, and it'll look nice this time. I promise.
Right on. Well, good job, man.
Oh, thank you. I like this orange. It's nice. It's popping.
Totally awesome. Yeah, that orange is gonna look good with the red.
Yes.
Yeah, I like that.
It's gonna be nice.
So.
All right. Now we're just gonna. Yeah, I'll do this later tonight. I'll take it off and I'll measure it out. Or maybe I'll just do it on a live. If I decide to do a live stream before Fringe Think Tank tomorrow, I'll do that on the live stream. But yeah, this is a nice frame. I like it. I'm excited to use it. And hey, we got the stereo amp receiver. It's supposed to come tomorrow, so we can do some more testing.
Really?
If it comes tomorrow, I'm definitely doing some more testing on live stream for sure. Because we'll mark out the neodymium sphere this time.
Huh. Right on, yeah. For sure. I can't wait.
Thank you, everybody. Thank you, Charles.
Hey, guys, thank you for watching. I'll let Ben get the last word. It's his stream. Thank you, everybody, for listening to me today and everything else. But Ben, thank you for building that coil, man, putting it together, and I can't wait to see it all done and you start testing on it.
Yeah, it's exciting. And before we end the stream, I just have one more segment to do. I'm going to go over to the mini lab over there and just go over the materials list that everybody's going to, all the equipment that everybody's going to need to do this coil class when I have it. It's either going to be on the 1st or the 8th, depending on when I get the actual bundle of the spool of coil.
All right, Ben, you take care of that. I'm out. Have
All
a
right,
great
Nathan.
day, guys.
I appreciate everything. Thanks for stopping by. This is like Mr. Rogers' Neighborhood. People just stop by and so yes, give me 1 second, guys. I'm gonna pull that up. Let's see.
Hey, Ben, you got no sound. Ben, you there? Sorry about that, guys. I was trying to turn it off. I turned on his live stream and he had no sound. Benny,
Can
you
you hear me
there?
now?
There you go.
For some reason, when you go off stage, sometimes the sound works and sometimes it doesn't. The mic?
Oh, I have no idea what it is, man.
Yeah, no, it's weird. Sometimes it'll work for you and sometimes it won't. Anyways, I'm just going over the materials list. Sorry, you guys missed all that.
You may have to start over because I don't think anybody heard you for the last.
Yeah, I am gonna have to start over.
All right, I'll remove myself. Have fun, Ben.
Thanks, Nathan. All right, so sorry about that. StreamYards was glitching on us. First thing you're going to need is the most important thing to run a setup like this. Aside from the 2 multimeters and the Arduino kit for rigging your circuits, however you want them, if you want them rigged like mine, just a basic Arduino kit will do. You might need 2 Arduino kits to do the reference circuit, though, because they only come with 1 fan. Now, you're also going to need a stereo amp receiver, something that has the ability to do left and right channel. So you, unless you're not doing the reference circuit, in which case you only need 1 channel. So, but you need the speaker, you need the ability to put the speaker wire in the back. So it's not just going to be a digital one. You have to have the speaker wire capabilities to plug it in. And also, you also have to have the ability to have an input of some sort on your stereo amp receiver. So you want to be able to put in some kind of signal, like a tone, some way, whether it's Bluetooth or through the phono cable or whatever. Next very important thing that we're going to need is an electric screwdriver. This is going to be used as a makeshift tool to twist our wires into a smooth bundle. Now, let's see, the next important thing is gloves. You're going to need gloves. PPE is very important. Gloves, safety glasses, and if you're doing any experiments with the neodymium sphere or magnets, I highly suggest a hard hat and gloves as well. I'm sorry, hard hat and boots as well. And after we twist our bifilar into a nice smooth bundle, we are then going to spool it up with this bad boy. It's just a piece of PVC pipe. And it's the right size and dimensions to fit in the tore so you don't bend or snag the wire. You have to be very careful because we don't want to bend it, not necessarily. We want it to be smooth, like jazz. So we're going to use this also. This is PVC pipe. I'm going to cut a couple of notches on the side and smooth it out on either side so it doesn't snag. But those notches will be used to spool the wire. So we're going to go spool it around. And after that, we're going to need electric tape and a portable grinder. This is a Hardell. So we use this portable grinder in combination with the torch. So the torch, we're going to use the torch to burn off the enamel. And then we grind what's left off. So the torch is used to burn off most of the enamel, so we're not putting too much stress on the wire with the grinder here. Because if we sand it too much, we could, have microfractures in the end, and it could kill the wire. So we burn it and then we grind it. Very important. And then after we twist up our 2 channels, it is recommended by me. I recommend that you test the coil before you solder it. But after you solder it, you're going to need these. And these are little insulator coats, jackets, and they're different colors. And I recommend that you get at least 4 different colors. And this is very important because if you have 4 leads or more, you want them to be easily organized, and you want to be able to keep track of them easy if you're configuring your system in different ways, and especially when recording the data so you don't get confused. So I have 4 different colors that I'm using for the ends, and you use one of these heat devices. This is a Ewin mini heat gun, 380 watt, and you use one of these, and it heats up the heat shrink, and it just shrinks it, and you have a nice little insulator on top of the ends, and then you can strip it if you need to, or just make it look nice, and so it's safe, so you're not having any connections hanging out and touching anything. So that's the next most important thing. And finally, we have our zip ties. You're going to need at least 2 big bags of these, at least 2 bags like this for zip ties. And also speaker wire. So you're going to need speaker wire. And the final thing that you will need is some kind of cable if you need to hook up the stereo amp receiver if it doesn't have Bluetooth. So that's pretty much it. If anybody has any questions, drop them in the chat before I end the stream. If not, I'll go to my page. Make sure you subscribe if you haven't already and like the live stream here. But make sure you go to my page and go to live. And if you're interested in the class, go ahead and hit the notify button for the live stream class. It's already set up. I don't know if it's going to be the 1st or the 8th. One of those days, I'll drop another video with more information on that, depending on when I get the wire bundle, because I need enough wire for this. Again, we're going to count out we're going to measure out how much wire we need with this frame right here. It's a bigger frame than the frame that I'm currently using. So we're going to do all that and more. So if you're interested in the class, it's going to be an all-day class. It'll start around 7:30 a.m. And make sure you have all your equipment ready. Or if, you're interested in that, I do recommend that you leave a comment and introduce yourself, just so we have that information and we're ready to go. And I have some idea of who's in the class at that time. So again, I appreciate everything from everybody. If you haven't subscribed to Old Man Nathan's channel, make sure you subscribe to his channel. Make sure you subscribe to my channel. If you're interested in merchandise, I have a whole bunch of merchandise on my website, beneficencetv.com. And if you're interested in accelerating my research at all, I do need, I think it's only about $50, and I can complete my order for the bundle of wire. So to accelerate that, if you would like to donate, that is Beneficence TV Cash App. The link is in the description of my channel. And again, I appreciate everybody for everything. I appreciate everybody for stopping by. Shorts and lab coat, yes. Yes. I appreciate it. Yeah, cheers. Nathan saves the day. He said, how many parallel bars are in the inner ring, our outer ring, standard Rodin coil? So this is a good question, and it varies because there's different patterns. There's different frames that you can get for the coil, and it all depends on what scale or fractal you're using of the geometry. But mine, I think, uses 11 or 12. Thanks, guys. All right, you guys are awesome. You guys take care, and I'll see you tomorrow for our Fringe Think Tank. And if I get the stereo amp receiver, I'll see you before then for some testing with 0 Point Energy. All right, guys. Have a good night. Thanks, everybody. Oh, 1 second.